Yeah. So let's start. Okay, let me introduce myself also. I am Kanishanan and I am in the third year of in Triple IT Hyderabad for our guest users. Okay. So initially, what is ML? Like there is a very hype like ML. What is this ML basically? So basically, ML is the like I will not talk in the like term of internet languages or in the course language. That's why I have not made more slides because I will focus to just cover in layman languages things. This slide is also kind of say just a formality to put a slide. Otherwise, there are only links more. Oh, cool. Okay. So what is ML basically? So ML is a thing, an algorithm basically by which you can teach a machine to do some work. So let me give you a very nice example. Okay, just let me confirm is yeah, will the recording. Uh, Actually, I am not sure if it will be available for triple ITH students or not. Is there any voice? Oh, can you guys hear?
Yes,
We
we
can.
are audible.
Can you repeat? We can hear. Cool. You can see the screen also, right? My slides.
Yes, sir, yes, sir.
Cool. Okay. Part you may like maybe try to rejoin. Okay. Let me move now. Yeah. So what is ML? Let me give you a very basic example. Very basic example. So see, when you are a newborn baby, right? You don't know anything. This is really a practical example. Just listen carefully. When you are a newborn baby, or maybe there is some newborn baby, just try to imagine he or she doesn't know anything. He or she like literally doesn't know anything. The parents teach him or her, and then he tries to learn like some things. For example, if you are a small kid, maybe say 2 to 3 years, a 2 to 3 year kid, and you don't know who is dog and who is cat. For example, you cannot classify the animals. You can see that there is something, but you don't know that this is dog and this is cat. But right now all of us obviously know that if I gave you like if a dog's come in front of you and or if a cat comes in front of you, you obviously know that yeah, this is a dog and this is a cat. Then how do you know? Who told you these things? When you were a newborn baby, there was nothing in your mind. You didn't know that this was a dog and this was a cat, right? So how you came to know right now? So what happened basically, maybe someone told you that this is a dog, maybe he showed you some dog and told you that he this is a dog and this is a cat. That way you see a lot of dogs. Maybe you see one dog this day and then there some other day when you were small kids. This is like really true example, not a fun example, right? So then you came to know that this is a dog and this is a cat. Maybe for example you saw some 10 dogs or maybe 5 cats, and then you can classify, yes, there is some difference between dogs and cats. Maybe there are various breeds in dogs and various breeds in cats itself. There are different skin color and various other things too. But right now all of you can classify that this is dog and this is cat. How? Because once you see various dogs or maybe images of dogs, your mind trained trained that way that this type of structure, this type of like say being, this type of being is known as dog and this type of being is known as cat. So that way you got to learn those things. So like if you can learn those things, your mind can learn those things, then our computers can also learn these things. This is the key rule of ML. If humans can do anything, then ML can also do that thing. Whatever your brain can do, ML can also do. ML is just like say a replica of brain, you can say that way. Because today also we will be doing dogs versus cat example. That's why I'm taking this example. So this is the ML. ML is basically training of like basically an algorithm and training of the machine to learn new things. The way a newborn baby did, the way you did when you were kids, you were small kids, maybe 2 to 3 years old, and the way you learned that this is dog and this is cat. Okay. Yeah. Okay. This example is clear. Then I will take a little speed. Can anyone speak?
Yes, yes.
Yeah, cool. If it is not clear, then also you can tell, though this was a very simple example. Yeah. So now, like slowly, I will be moving on advanced topics too. So for the users who know simple ML, don't worry. We will be moving on advanced topic too. But like, I want to clear out some things. So that's why. Okay. So cool. This was the thing which, was the aim. What is the ML? This is just the like say internet definition of ML. So I will not go through this because obviously you can also go to the internet. Here you are to like understand what the things are. Okay. So now this. Okay. So now this is done. Now let us see. Like I today in the first part when I will be doing for computer vision, I will be doing a problem which is to, like, you are given a set of images of dogs and cats. You need to train a model which can classify an image as a dog or a cat. So you need to train a model to which, if I input an image, the model will say that this is dog or this is cat. Only two labels, right? So we will train this model. So now, before moving on to the code and before moving on to the technical terms, let us logically think what is the thing in the images of dog that a model can learn. Let me maybe open, oh, sorry, dog image. Yeah, see. So in this image, what can happen? See. So this is the dog image. How you see the image? Like, if you see, you can say this is a dog. So there are some things. See, see, for example, this is the grass and this is the dog. Like, maybe say some skin color or brownish color. So see, here the brownish color start, and here there is a green color. So there is a difference in the image colors, right? So this way, your model, treat your model as a black box right now. We don't need to know what is the math behind how this works. We will obviously see that, but right now, just try to understand that model will basically try to learn basically the way your brain learned. The model will also try to learn that, guys, this is the edge. See, this is the edge. This is the edge. This is the red thing. This is the black. So these are the eyes. When you, like, if I show you maybe some, say, a random animal who has two eyes, and then obviously you can easily classify na, that there are eyes present of those animal, whether you don't know what is the breed of the animal, whether animal is lion, tiger, or anything, but you can know that these are two eyes. Why? Because see, eyes are basically maybe of like black color or something of that color, but you know how eyes are. So that way our model can also learn. Like, basically, due to presence of these edges, these are curves, how so uh, someone unmute. Okay, I will mute. Cool. Yeah. So that way, model also learn various things. In images, model learn various things. So let me just give you a brief about what are neural networks, because neural network are the basic things upon which most of the ML things work. So neural network, I will not go into the details. The reason why, because many of you might have done end-to-end courses of ML, in which, you know, obviously he has explained a lot mathematically also, maybe taken some things to the abstract level and tried to explain what are neural network mathematically. But obviously we cannot explain it that in a 2-hour session. But yeah, anything you can just treat that neural network as a black box, and then you can obviously do those things. Because many of us, like many of the like advanced user who don't, like who are advanced user in ML, don't, might not be knowing entire math behind neural network, and obviously it is not possible to cover it in 2-hour session. So yeah, so neural network is basically, say, a kind of like very like highly complex mathematical function which can like output something, right? Just treat the neural network as a black box to which you input something and he gives you an output. How he gives you an output? There is some mathematical function inside it to which, like, which learns. You can treat neural network as your brain, like, to which you feed your basically images of dogs and cats. Like, you told your brain, or maybe say your newborn baby's brain, that hey baby, these 10 images are of dog and these 10 images are of cat. So you learn these things and then give me a prediction. And why, the reason why I am taking this as a black box is because in the code walkthrough also, I will not be writing this neural network, because today we are living in 2021. So most of the models are already present as a library. You just need to import them and run. So why do we care about like going into deep detail right now? Obviously it is good to know the details also, but yeah, I'm just talking about getting a beginning in the ML, right? So this was about neural network. Now what is CNN? CNN are basically, yeah, CNN are basically convolutional neural network. So what is this convolutional thing, right? So basically CNN are mostly for images. We can use it for other purposes also, but mostly, but you can say this way, if there are images in your problem statement, then CNN is definitely going to come. Like, there are 95% chances that you will need CNN. So what is CNN? CNN means convolutional neural network. So there is only one term additionally, convolutional. Neural network, I already told you that it is a black box. It is a highly complex mathematical function to which you give an input and it gives you an output. So, but there is one step behind that neural network, which is a separate step for images. What that step is, like, I gave you the image, right? Yeah, I told already 2 hours. Yeah, yeah. So there is one step behind before this, what you say, neural network in the in the images task, that is known as convolutional blocks, or this way. So what is the role of that block? So what that block does, if you feed that block an image, maybe this image or maybe say this image, so basically that that block tries to understand the meaning of this image. What are the features from this image? Like I will tell you, there are lines in this image. I'm not talking about horizontal lines. Say this curves this way, the boundary of this dog. There are different colors. This is white color. This is brown color. This tongue is also present, so pink color. This nose of black color, and nose also has a specific shape. So these all are the features from this image. If any of you might know CV, about OpenCV library, he or she might be knowing how to get the lines from this image and all that stuff. So that is the role of convolutional blocks. So, but we are taking this as a black box. Why? Because for a beginner, like going into exact detail of how this is working and all, that is not possible according to me. So right now, I'm just giving you an intuition, and then I will be moving forward. So let me just quickly give a recap. Neural networks are like we will treat neural network as a black box today, and these are highly complex mathematical functions to which if you give an input, he gives you an output. But there is one thing: a neural network is, say, a kind of a dumb guy. He does not understand the images. He understands, say, array or numbers. So what our convolutional block does, that, our convolutional block is a, say, a smart guy. To that smart guy, if you input an image, he or she will understand some of the features from that image, maybe lines, maybe colors. He is a smart guy. Like he is a, like, say, a CV tech guy, you can say this way, right? And he will basically convert that image into numbers or an array, and that array he will give to our neural network black box, and our neural network obviously understand those things, and it will give us an output. So till now, is this clear? Then I will move forward. If anyone is not clear, do ask. What is CV? CV means computer vision. Please don't hesitate. Just ask any doubt. Like this is a session for you guys only. Okay, cool. Anyways, we were treating it as a black box. So now, yeah. Okay, cool. Now I will be moving on
What is
towards
black
the.
box here?
What is black box? So black box is a, say, a kind of a thing, like maybe say a box of cardboard to which if you like, you just need to don't need to go into the details of that box. You just treat it as a dumb like a smart guy to which if you give an input and he will give you an output. That way only. So your voice is not getting clear. Could you elaborate about CV? I don't have enough practice in arrays. Okay, I will not. I am not going to take arrays in the code today. It was just a method to explain. Code is pretty simple. Like, just trust me. Code is pretty simple. It is just like an English language. Okay, could you elaborate about CV? Like, don't need to. You don't need to go into the details of CV. CV means computer vision. Like, basically how computers understand the images. Basically, vision of computer. Like your eyes are the vision of your body. That way. All functions are inbuilt. Yeah, yeah, Abhishek, right. Okay, cool. So where was I? Yeah, yeah. We did the black boxes. Now I am moving forward to the code. So our problem for today is, like, I already told you, given the set of images, train a model for dogs versus cat classification, and then you need to predict upon those images. And now with this model, I will be teaching you various advanced techniques also. So now, like for advanced user also, like you might feel like some things are very useful. Let me give out you the link. Okay, let me tell you one more thing. So today we are using Google Colab. So what is Google Colab? Just a brief if someone don't know, like, because one person
Person
asked.
asked.
Okay, please unmute. Oh, sorry, mute. Sorry. Yeah. So Google Colab basically is an online notebook on which you can code, and it will not take like computation power of your laptop. Why we use Google Colab? Because machine learning requires GPUs many times. GPUs are basically graphical processing unit. Like there are CPUs in your system. Maybe some of you have GPUs also. But why to give load on our computer if Google is providing us Colab notebook, right? And it is like pretty good. It like if you turn like basically if you move away from your laptop, then also it will be running. So you don't need to install packages in your laptop. You can just install packages in this notebook itself. So this is a kind of, say, environment to provide it to you, and it has a lot of packages already there also. So you most of the time you don't need to install any packages. As one guy asked the question, like today also I have not installed even one package, and entire notebook is running, right? So this is the Google Colab. Okay, just like not for this notebook, just a general thing. If you want to change the runtime, go to this runtime option, change runtime, and like check on this GPU option, right? If you have highly computational things, let me give you this link also. I'm giving this link in the chat. You might run the cell like together with me, but I would advise to understand this first, and after that you can maybe after the session you can try to run. And also, I have not provided obviously I have not provided the edit access on this notebook, so you can create a copy. There is an option coming here in the file that save a copy in drive, and then you can run it. Cool. So this is the link of our first notebook, and along with this, the dataset I have provided in the this drive in the dog versus cat section. There is a file. Okay, let me delete this thing. Yeah, there is a file data.zip. So this is the data. So I will share you this link also. One second. Okay. Yeah. So this is the link of. Okay. What about the sample data? Is there any way to store it there and not upload it again and again? Yeah, yeah, very nice question, Pranjal. So what happens is this was a nice question. So what Pranjal means is like if you want to access the data of your computer in this notebook, obviously you need to like the data is the core thing of ML. So one option is that upload it here, but why to upload again and again? Why to download in my laptop? So what you can do is Pranjal, you can upload your data to the drive and just link the drive with this collab notebook, and it will automatically take the data from your drive. And if you want to save something, as we do today also, you can directly save the data into this drive. So you don't need to upload it again and again. You can just upload once on drive, take it from drive, and save it to drive. That's why I've provided you the drive link of the dataset. Cool. Is it clear, Pranjal? Okay. So yeah, I've provided you the dataset link, but you need to create a copy, and then only you will be able to access it in your what do you say notebook, because obviously I have not given you the all the access on this drive. That's why. So yeah, let's start now. And this is the challenge link. I've already provided in the notebook, so I don't need to send it here. Uh, I've taken this
Hello.
challenge from Kaggle. Yeah.
Am I audible?
Yeah, you are audible.
Yeah, actually, I am not able to open my meeting chat. Means, can you show me how to open it in Microsoft Teams?
Just click on this button. This
Which?
one. This one. Like here, you can see the participant, and here you can see the chat, right?
Okay.
Yeah,
Okay.
cool. Yeah. Okay. Yeah. So I've okay. Just yeah. I have provided this link, and yeah. So and this is the Kaggle challenge. So if you want to make a submission after this workshop, you can obviously do that also, and I will encourage you to do that. So firstly, I have done some imports. So I have imported some packages which we are going to use today. But I will explain these packages side by side. Okay. Not everything right now. So first run this cell. So this is cell wise. This notebook is cell wise to the guys who don't know about notebook. And see, as Pranjal asked this question, like here we are mounting the drive. You can mount the drive. What mount means? Like basically your drive will get loaded to this collab notebook, and then you can access all the content of your drive, full contents. If you want to see any images and videos, then also you can see here. Like for example, if you have a very just out of context, if you have a very like say a very large file and you are not able to load it in your computer because of say your computer is not much computationally like powerful, you have like say only 4 GB RAM that way, so you can just use collab here. Cool. So this is the code to obviously this is a library. Okay, sir, please speak a bit slow. Oh, sorry. Yeah, sorry. Cool. Okay. So this is the code to mount the drive on your collab notebook. Let me just run this cell. This is just a library command, so I don't think I need to explain this. And this URL comes first because obviously he needs the ID also. I will log in with my ID, and that way I get this link. I need to just copy this link and paste it here this way, right? And this is running. What is authorization code? Yeah, I told you na. I guess now it would be clear, right?
Could you repeat? I missed it.
Yeah, actually, while mounting the drive, you need to tell the collab na that from which email ID you want to basically mount the drive. So
Right.
that authentication code, just when you will run this code, this one, there will be a link. You need to open that link, and then basically there will be a code, and you just need to copy paste it here, right? Cool. So yeah. So now you can see as my drive is loaded here. Yes, see this drive. This cool. So this is
Yeah.
the drive. How to mount drive, sir? Confused. Oh, you don't need to understand this code. Basically, you just need to run this code, and automatically the things will be done. You just need to run this code and just log in with whatever email ID you want to do. You don't need to understand this thing, na. This is just a library, right? So now my drive is mounted. I can see all the contents of my drive. Obviously, I will not show you my contents, but yeah, see in my drive, in this ML workshop folder, inside this dogs versus cat, there is a data.zip. I want to unzip this file. Now this is my data set. So I mentioned a command unzip minus q is for just not printing the output. Don't worry about this. And here I have mentioned the path of my file drive slash my drive slash ml workshop slash dog versus cat, which is the folder name and which is the file name, right? So I just need to mention the path. And what is this unzip? This is just a Linux command. You can, many of you might be knowing that you can run this directly in your terminal. And whenever you need to, there is a feature in Collab Notebook and in Jupyter Notebook also that you can run the commands of your terminal also easily inside your notebook. For that, you just need to put this exclamation sign here. For example, say, okay, I will show you that afterwards maybe. So unzip is a command of Linux, but you can use it here also with this exclamation sign. So I am unzipping my data. So what I did, I basically uploaded this file to my drive and mounted my drive, and thus then I am unzipping the data. So now as you guys can see, you see here is a data folder. It unzipped and the data folder is here. Okay. So these are some constants which we will see as we move forward. I will explain you this, what is the image weight, height, channels and batch size and epochs. Don't worry about this. But the good practice is just defining them beforehand. If I forgot by mistake to explain this, just remind me maybe. Authorization code. Oh, you don't need to understand what is the authorization code. It is just a code like which tells from which email ID you want to like for which email ID drive you want to mount basically. So you don't need to like focus on those things. That was just a, like to make the things convenient, right? So yeah. So first thing in ML, just first thing in ML for any problem is you need to first see the data. It is known as this EDA. EDA means exploratory data analysis. So basically you need to see, okay, sorry. Yeah. You need to see first what is your data. Then only you can make the decisions like what is the best model for you, how will you train the model, and what are the specific things. So this is the best, like most important thing in ML. Why this is the most important? Because the training part is pretty simple. Why? Because most of the models are available on net. You just need to import them and run. So that's way it's not a tough task. But this is like say an interesting task of ML of watching the data to understand what your data means. So data is the like say like most important key thing of your ML problems. After mounting drive, what to do now? I'm confused. Array, after mounting, you don't need to do anything, na. After mounting your drive will be loaded in on your Collab notebook, and you can see all the contents of your drive here only. So you don't need to worry about that. So now you can access all the contents of your drive. Maybe let me show you if you guys are confusing a lot. See, this is the ML workshop, and I have this is the dog versus cat folder, and in the images I have this one image which I have used in this notebook. See, and I can open this image here. So it just does a simple thing, na. Just load your drive and you can see the contents of your drive. It is asking authorization code. What we have to fill there? Yeah, there is a like first advice would be don't run it right now, because if you're running it like together, so then you will not be able to see the screen, na. How will you understand that way? And just telling the answer that the link, there is a link, click on that link and you will go to the login page, and then you will get a code and you just need to copy paste. Yeah, Abhinav, I will tell you what are the epochs afterwards, like after, I mean after EDA, Why I have defined them here? Because it is a good practice to define the constants beforehand globally. So just remind me if I by mistake I forgot, but I will not forget. So yeah, I will explain you what are all these things. So don't worry about this. This is just a simple data path. I mentioned the
Hello.
data path. Can we get the
Uh,
recording? No,
yeah,
Saksham, you won't get the recording. Sorry.
I have
Uh,
one problem.
yeah,
Hello.
tell, tell
Yeah,
Tejas.
yeah. Actually, I am not able to open my meeting chat because it is showing that chat in channel setting is only available to team members.
No, many users are doing. The guest user are also doing so. Like maybe it
Yeah,
is
but
some.
No,
it is
even I'm
inactive.
facing the same problem.
Same
Oh,
problem.
Means the icon is inactive.
oh, you cannot open the chat section.
Yeah, yeah, yeah.
Uh,
Yes, sir.
but Abhinav, you were able to message. Na, you are also a guest.
Yes, so we
Yeah,
can
I
we
was
can
able to
actually
message.
access it. We are not facing problem. Even I'm accessing my chat box.
Yeah, then
You, you,
why?
you need to join the team. If you need to join the team, like you don't just join the meeting. If you join the team, probably you'll be able to access the chat. Like if
Yeah, but how to join the team? Means we did not get
like you
any.
got the code of the team, I think you like enter that and you can join the team.
No,
Like
for the guest user, you got an email. Na? You got an email to join the code, and
Yes, yes.
oh, maybe that's an issue. Like when you paid your like fees for this thing, you filled an
Yeah,
email, and on that email we gave sent you an invite link for this team channel. Na?
yeah. It was there, but it was for the CP programming, not for ML. Means today's.
You didn't pay for ML1.
No. I am paid for all course. Means
Oh, you
free
took
of
the combo
charge.
one.
Yeah, yeah.
Uh, but the link, like email ID would be same, so I don't get the recording after.
I joined the team mail, but I couldn't open the chat box.
Okay, maybe it's not available in web version. No, I am also using the web version. So, okay, I don't know what is the glitch here because everyone, like many guest users are able to do that. If it would be that only triple ID user could do it, then I could check. But right now, what to do after copying the sign code? Yeah, just click on enter. But I will advise don't run it right now because you are getting doubts. So just focus on the screen first. Yeah,
Okay.
Tejas and all the others who are not
Yeah.
able to like put the message on chat, you can unmute and ask directly because I also cannot do anything right now, right?
Okay.
Yeah, just mute yourself. There is a lot of noise from your side, maybe.
Hello, am I audible?
Yeah.
Yeah, actually, there is an option to show conversation right next to leave meeting or hang up, I guess.
Yeah, I told him that only, but
But
he's saying that
yeah, we can actually reply. Like I am a guest user too, so
yeah,
I
I
can
also don't
reply.
know like because many guests are able to do. So maybe there is some system issue. I don't know like what happened, but yeah, just like forget this. We don't have much time. So yeah, just let us move on. Yeah, so we were here that I told that data is the most important thing of any ML problem. So we first see the data and then we decide what are the models. Right now, I already told you obviously that this is a computer vision thing, so you know what model to run. So see, okay, 1 second. Yeah, so this is a data for pre-processing. Let's first see some images of our data set. I will run this thing. Data path is not defined. Oh, I forgot to run this cell. Sorry. So here we are seeing some random images of a data set. How I am able to see? I have applied a for loop and I am just picking an image randomly from this data path. What was the data path? This unzipped data folder link. So these are some of the images present in a data set. See the cat image, dog, cat image, and see one important thing which I am going to use right now. What is the image of this? Sorry. What is the name of this image? Cat dot 1247407 dot jpeg. So naming is this way. For the images of dog, there is dog, then some number, then dot jpg, and for cats there is cat, then some number, and then dot png, right? Oh sorry, dot jpg. So this way we were only given basically the images, we were only given the images in a data set, right? We were not given any mapping. So, but we need a mapping now. We need to tell our black box that this image is of dog. So what I'm going to do now is in this code is that I will basically from like in the name of image already it is written that whether this image corresponds to a dog or the image corresponds to a cat. So I will make a list, and in that list I will store. Oh, just 1 second, I'm getting the important call. 1 second, just. Can, can you guys see the screen, right? Someone messaged that he cannot.
It's visible.
Cool, then maybe it's issue on your side. Cool. I'm moving forward. So you were given images only in the dataset whose like file names were like file names contain dog, either dog or cat. If the image corresponds to dog, it is written dog and it is written cat. But I need a mapping. So what I'm doing is I'm storing some way. I will tell you how. I'm storing in a say a data structure or something the file names and corresponding labels. How labels? If the images of dog, how I identify images of dog? Because the first three letters of my file name represents dogs, D-O-G, right? And if it is a cat, the first three letter of my file name represents cat, C-A-T. So I will put the labels accordingly. So this is the code. What I am doing here is, see, os.list this, os.list this. It gives you a list which returns like all the contents present in this data path folder. And what my data path folder contains, it contains all the images, right? So these are the file names. I'm looping over my file names for image in this os list here. And what I'm doing is I am splitting the image by dot. What it means is like, see, the names were dog dot some number dot jpeg, cat dot some number dot jpeg. So I'm splitting it by dot, and the first part, if the first part is cat, then I'm appending 1 to my labels, and if the else, I'm appending 0 to my labels. So what it means is for all the dogs, I'm appending 1 corresponding to that file name, and for all the cats in my folder, all the files, sorry, all the images of cat in my folder, I'm appending 0 to my file names, right? Cool. This would be clear because this is a pretty simple thing. These are the names, and obviously this won't occur every time. So that's why I told you that first we need to see the data. Like here we saw the data and we see that they have only given to us the images. The Kaggle people have only given to us images. So we need to prepare a mapping on our own. So now this is a, maybe many of you might be knowing, not be knowing these things. So there is a library known as pandas. I mentioned the link here also if you want to study this pandas library. This is a very important library whenever we are doing this exploratory data analysis. So this is like this offer a thing, very important thing known as a data frame. What is a data frame? Data frame, you can treat it as a like of a table. It is just a table which has some number of basically. Okay. Oh, so slow, cool, sorry. Yeah. So this you understand. Now I'm moving forward to the pandas data frame. So what is data frame? Basically, pandas is a library which offers a very important thing for our EDA, which is known as a data frame. What is a data frame? Data frame is a kind of a table. Table, you already know na, what table is. So in the table there are various columns and various rows. So right now what I want, I'm telling you, I want a table in which there are two columns. One column's heading is file name and other column's heading is label. And the file name column will contain the names of my file, all the file names, all whichever I have, whichever are present in my data, and the labels will include the corresponding labels. Basically, that this file name corresponding to this file name label is dog or cat, and I have represented dog by 1 and cat by 0. That I already told you. So that way is our data frame. Let me show you the data frame. That way it will be more clearer. See, let us see our data frame. See, df. Okay, we just need to write df. Okay, to run this cell, let me tell you one more thing. To run this cell, one option is go somewhere here. There is some button and run the cell. But an easier option is go to this cell, press shift enter. Shift and enter together. And this will run the cell. Cool. So see, this looks like a kind of a table, right? And there are two headers, file name, category. There are images name, cat.1489.jpg, and the label for cat is 0. I already told you I represented cat by 0 and dogs by 1. For this file name label is 1. So you can see this is a kind of a table, right? So this table, this pandas basically pandas library give us this feature of using a data frame, which is a kind of a table. So why this is useful, I will tell you just now. First tell me if this thing is clear, the data frame, pandas data frame thing. Let me comment also. And what I pass to this data frame, see, this is the name of my column, file name. This is the name of my second column, and this is the list of all the all these values, like what all these things this column will contain, and the corresponding labels are also present, right? I am basically labels.append 1 and labels.append 0. This is my list, Python list, and I am just appending 1 or 0. And file name was already a list. Let me show you that also if you want to see. See, let us see labels. See, it is a list, a long list because there are a lot of data points. And this is my file name. See, these both are list. Like you can check with type also. This is a list, right? So you just need to pass both the list here and it will make a table. So this is a very important thing whenever, like mostly in the ML, you will be using this pandas data frame. Where did you specify in code that cat is 1 and dog is 0? Let me show you again. If else, yeah, very nice. Yes, sir. How the system recognizes that whether it is a dog or a cat? Which system? No. Firstly, answer of first guy, Abhinav. See, here I said val if val is equal to 0, labels dot append 1. Otherwise, labels dot append 0. As one guy told already in if else condition, and other guy told, see, I showed you the images. This was the dataset which Kaggle provided me. I showed you also here which Kaggle provided me. So in this dataset, there were a lot of images, and for the images of dog, this was the kind of name, dog dot some number dot jpeg, and for the cat images, this was the name. So what I did is I took the first three letters from this file name, which is just a Python thing, basically splitting this name by dot delimiter. Or what you can do is just, if you are not familiar with this thing, you can just take the first three letters of the string by indexing or anything, and just I checked if that is equal to dog, then append 0, else append sorry, if it is a dog, append 1, else append 0. Sir, how? Okay, sir, how using the name of file, this is training data. Yeah, Rajat, can you repeat what panda library is? Yeah, I will tell. File name of image contain dog in name if it is dog and vice versa. Yeah, thanks. Okay, can you repeat what pandas library? Yeah, so pandas is a library which we use mostly for EDA purposes. So it offers a lot of things, obviously, but the most useful and most famous thing you can say of this library is data frame, which is the most famous thing. What is a data frame? It is a kind of a table. See, this looks like also a table, na? That there are columns and there are rows. So what I did right now is in my data frame, I pushed I made various rows, and what each row represents, each row has a file name and each row has a label according to that. Cool. Who asked this? Okay, I understood. Cool. Yeah. Yeah, Jashan, you can ask doubt if you want. You have raised your hand. And also to the guys who are not able to put the message in the chat, I encourage you to maybe unmute yourself and ask the doubts. Palav, there is noise from your background, so I am muting you. If you want to ask any doubt, you can unmute yourself. Yeah. So yeah, to the guys who are not able to message in the chat, not reply, you can just ask any doubt by unmuting, because I also don't know why it is happening. Because for most of the guests, see, these are also guests, you can see in the names, they are able to message. But few are not, maybe that is their system issue or maybe some version issue, I don't know. So that way, yeah. So is this panda?
सर ऐसा पाइथन लैंग्वेज चल रही है, क्या चल रहा है?
हाँ, पाइथन
सर हमें तो सर ये लैंग्वेज पढ़ा ही नहीं, अभी शुरू नहीं करवाई सर.
Python was a prerequisite, it was written as a prerequisite while registering, right?
Okay, sir.
Yeah, but I will try my best to basically tell from basic, but obviously I cannot tell the Python right now, na, because the session is ML. So yeah, for now we are just reading the stuff before ML, right? Yeah, yeah, very nice. Yes, we are doing this only. And how we are using doing this? We are splitting the string, the file name string by dot. Okay, sorry. Yeah, yeah. We are splitting the string with the functions dot split. It is a very easy function. You can see it is a Python function. I am in first year. I have studied bit of C++. Yeah, I understand your concern, but I also cannot do anything right now, no, because like Python was prerequisite because this is a session of ML, so I cannot teach Python, na, because it will take like very lot of time that way. So maybe like you can treat something as a black box. Like if you know C++, you might be understanding what is a for loop. So that way it will not create major issues, right? So just tell me one thing: is the data frame thing clear? If it is not clear, I will repeat or else I will move forward. Yeah, very nice, Rajat. Yeah, tell me, is the data frame thing clear? Rajat, you tell me. No, no, it is not a like sort of SQL. It is a data frame. Yeah, you can say like not SQL, not a part of SQL, but yeah, it is also method to store data. So maybe you can consider it gives us a table. Yeah, 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 yeah. So I am in class 9. Oh, and I can understand its basics. So very nice. Okay, then I am moving forward. If no one is asking doubt related to the data frame, so you can see the data frame, right? So I told you, showed you the images also. These are just the random images. If I run this again, images will change, right? Because I just choose them randomly. Yeah. So this was a data frame. I already tell you. So there is a command like function to basically see the shape of your data frame, the size of the data frame. You can do that by using df.shape this way. This is the function df.shape, and this way you can see the shape. Okay, sorry, okay, sorry, it is, sorry for that. Yeah, so basically it shows you the size of your table. This is the table that this cross this. There are 2 columns and this much rows, right? So what will be our dataset size? There are total 25,000 images present in our dataset. By df.shape we checked already, right? And also there is one more very important thing, df.head. What this does is it shows you the first 5 columns of your data frame of your table. Shows first 5 rows of table. I am writing table just for your convenience. If you want to see 10, you can just mention 10 here, and then you will see the 10. So you can treat it as a table and just see some rows, because you obviously want to see what is happening, right? So that way, yeah. So yeah, this was the data frame. We also saw that our dataset size is 25,000 total images. There are total 25,000 images. So yeah, cool. So for this specific problem, Kaggle only provided us a dataset containing images. Till now, at what stage we are? We are at a stage at which we prepared a table. I'm not telling data frame right now, so don't confuse you. We prepared a table in which there are various file names, obviously all file names, and for each file name there is a corresponding label. Which is represents, if it is 1, it represents that this file name is an image of a dog, and if it is 0, that then this file name is an image of a cat. Cool. So now there is very important. So this was much about our EDA, exploratory data analysis, to see the image, to load the data in the data frame and see our tables, and this way. So now let us move forward to one more important thing of our ML. So in ML there are basically 3 types of data. First is training data, second is validation data, and third is test data. So first let me tell you what is training data. To the brain, the first example which I told you, to the brain of a newborn baby, you will feed him some images. Now you will tell him that, hey, these are the images of dog and these are the images of cat. You need to learn from these images. You need to learn how to classify an image as a cat and how to classify an image as a dog. So that is known as a training data, which your model, which your algorithm, or which your black box neural network black box will use to learn the features of the image, right? That is the training data. Let me come to test data, and then I will come to the validation data. What is the test data? Now, on the for the challenges like Kaggle, they provided test data for which what you need to do, you need to train a model from your training data, cool, and then you need to make the prediction on your test data. Like for example, uh, let's take an example of the baby. To the baby, you told him 100 images. From the 100 images, say 50 images were of the basically dog, 50 were of the cat, and the brain of the baby like processed those images and learned like how to recognize an image as a. Sir, why is it df.shape0? Oh yeah, I will tell you. Just 1 second. I will tell you. So what I was saying, yeah, to the baby you fed 50 images of dog, 50 images of the cat. So your brain, the brain of the baby, used those 100 images to process, to work, and then to learn the features. And now my baby's brain is basically able to, what do you say, classify an image as a dog and a cat. Now I want to check if the baby has learned properly or not. So what I will do is I will give him a new set of images and I will tell him that tell me if this image is of a dog, this image is of a cat, and then I will check, like for example, if I gave him 5 images of a dog and 5 images of a cat, total 10 images, and now I will check how many images does the baby answered correctly. So that would represent how much, like how good the brain of the baby is. One important thing to note here is I will not give the training images as the test. So what I mean is, like initially I gave 100 images to the baby. So I will not basically test upon those images. Why? The reason, can anyone tell me the reason of this thing? Anyone? That why I cannot use my training data only as my test data? Any guesses also would work. It trained on it, so it already knows. Yeah. Nice. Answer to that is because our model will learn on that data. Very nice, very nice. Already knows because he or she already knows that it is yeah, very nice. Because he or she already knows that this is a dog or a cat. So yeah, so we will not be able to recognize that if our baby has learned it or not. Like what the baby can do is he can just wrote those images. जैसे कहते हैं रट्टा लगाना, so he can just wrote those images that this images of a dog, this images of a cat. He will just learn for those images, and he will not logically he will not understand. So that way we need to basically test on a new data set so that we can learn. Oh, sorry, we can know that if our model has truly understand the logic behind it or not. Cool. So this was okay. So
Yeah, brother, I have one doubt.
yeah.
Yeah. So this machine in which we are putting this data, so it will it will only recognize those or distinguish those images which we are giving them. Means it will not recognize or distinguish those images which are apart from this list, right? Like
No.
suppose if we like suppose if we shoot one if we means if we pick one image like yeah, and give it as an input, then can't it distinguish like it is dog and it is cat?
No. Yeah, that I told already right now. No, that your baby will learn on a given set of images, and now your baby is like his brain is not a dumb brain. His brain is a smart brain.
Yeah.
So he will learn that this type of creatures are known as dog, and these type of creatures are known as cat. Like for example, you can also recognize who is a dog and who is a cat.
Yeah.
If I tomorrow if I show you some new breed of dog, then also you may not be able to answer that what is the breed, but you will be able to answer that if this is a dog or a cat, right?
Yes.
Even
Means,
when you are not shown the image of dog previously, right? So that way also machine learning
yeah.
model will learn if the model is good enough to understand the things logically. So that is the
So
a measure, yeah. So that is a measure to
yeah. Machine is also able to recognize it, right?
yeah.
Okay.
Yeah, so answering this question, okay, what is the random state? Where I took the random state? Oh, I will tell you. Yeah, wait for 1 minute. Yeah. Why it is df.shape0? Yeah, this is because df.shape. I showed you where I showed you. Yeah. See, let me show you again. See, df.shape returns two things. First is the number of rows and second is the number of columns. So what would be the size of my data set? It would be number of rows. So this is the list. So this is say 0th index thing and this is the first index thing. So that way I have printed the data set size. That way I have taken df.shape.0. Oh sorry, 0 index 0, right? I will tell you what is the random set. So now training data is clear, test data is clear as it is shown on messages also. So now let us see what is the validation data. It is also a very important thing on our ML side. So basically, what is the DF thing by the way? I told you that the DF is data frame, basically a variable. It is a kind of a table. So what is the validation data? See how the machine learning algorithms works. It is a bit technical. The training and test was not that technical, but training and validation is a bit technical. So how our algorithm works, it tries various parameters. Like you give him the training data, it tries various parameters on the algorithm on that training data and checks the performance on the validation data. And for like from among the all the parameters tried, for the parameter for which the performance is based on the validation data, he will give you an indication that use these parameters. Why it is so? Because like if there would be no validation set and you will just train on the training data, so your model will just basically route the things. He will just learn on those set of images that if this image come, I will tell dog. If this image come, then I will tell cat. You can treat it as just a kind of an if-else thing. If this image, then dog. If this image, then cat. But we don't need that thing. Na? Your brain is not like that. Your brain is a logical being. So your brain understands what is a dog and what is a cat. So we need that way. So for that, what we do while training process, we train on some data for some time and then we check if the performance for this set of parameters is good on validation set or not. If it is good, very good, continue with these parameters. If it is not good, it will give an indication to change the parameter. So this way, training and validation basically data set are consumed. And at the last point, I will. Okay, sorry, there are doubts. Oh, okay, sorry. Yeah, Kunal, just okay, sorry. Yeah, so this way training and validation data are used at the time of my training and test data is used at the last time, just if I want to check if actually my basically model is learning or not, or to submit the prediction on Kaggle or AI crowd or something. So is this thing clear? Then I will move forward. Okay, can let me ask some doubt, but just wait on this. Okay, just leave. Yeah, are you clear with this training and validation thing? Anyone? Yes, cool. So yeah, so I am moving right now. So as I already told you, training and validation are needed at the time of my uh, training the model and test at the last to give the prediction. Yeah, cool. No, sir, please explain it again. What point is not clear? Can you tell? What you meant by
So
change?
validation data.
Yeah, I will tell you. Hardik also asked what you meant by changing the parameters. See, very nice question, Hardik. So what is there? See, I told you that neural network is a black box, right? So basically, neural network has a lot of parameters. It is a mathematical function. See, there is a mathematical equation ax plus by is equal to c, right? So a and b are the parameters of that equation, right? So these are the same way there are parameters for neural networks. The black box, the math things which we take, which you don't need to understand. So those parameters basically improve the performance of your model. So while training, we improve those parameters so that we get the best parameters at the end, which understand our problem and which give the prediction accurately. So what happens is, like while training, our model tries a lot of parameters. Like you are training, it will see what are the features in the training. It will try some parameters based upon my training thing, and my model will see if those parameters are good enough and are working on validation or not. If they are working, very good. If they are not working, it means that my model was just learning to on training set and he was not able to understand the things logically. Because obviously, if he is going to understand the things logically, he will give good output on validation set also, right? But so that way, those are known as the parameters. So if the performance is not good on validation set, I will change my parameters. I will change the value of say a and b. Obviously, the equation is not as simple as ax plus by is equal to c. I will change the parameter, try again, and that way I will move forward. Is it clear, Hardik? And someone else also asked a doubt. I forgot her name. Is the validation thing clear right now? If anyone, for anyone it is not clear, just put a message or just unmute. Okay, cool. Okay, so we have training, we have validation, and we understood what is the test data set. So now in this problem, for this, like on platforms there are a lot of problems. Some platforms, or for some problems, they already provide you training and validation data set, but for some problems they don't provide you training and validation. They just provide you a set of images or a set of data together, and they said make the validation set on your own. They don't care about this. So this problem is also of that kind. They only gave us 25,000 images, and they don't tell that use this at training. Like what? Like it doesn't matter to Kaggle, na? Like whatever I will use validation. It's my wish. Why would it matter to Kaggle? They only want the output on test data set. So they will provide me test data set and one other data set. So this was my that data set, the DF, the 25,000 rows of my this table represents full data given to me by Kaggle. So now I will split this table into two parts. I will use some part as the validation and some part as the training, because I don't have the validation right now. I have just a dump of 25,000 rows. I will like assign some rows to the training and assign some rows to the validation. Now the thing is, how many rows to be assigned to training and how many rows to be assigned to validation? Can someone answer this question? Like I gave you 25,000 images. Just tell me the ratio or anything. How many images should I assign to training and how many to the validation? Any guess would work. Hardik, you tell. I will just like pick up random names.
Anything 80-20.
Yeah, why 80-20? Can you like make a guess? Why not 50-50?
More is the test case and more is it chances like it will have more text too.
Okay, Abhishek, why 80-20? Yeah, thanks, Hardik. Abhishek. Or Shaurya, maybe like anyone can answer. I'm just pointing out the name so that you speak, and it is an interactive session.
So the question was, why do you have a train case of 80 and a test case of 20, right?
I asked you. I don't tell you that take 80-20. I asked you, and some of you guys told me that take 80-20, and then I'm questioning you why 80-20.
So because like you can train majority of your data on like 80% of the data set.
Yeah.
And like that is good enough to like get enough training data, in the sense like you can train 100% also, but even 80% is enough, and then the remaining 20 you can use as validation or like testing, and you can recheck your model.
Very nice. Okay, you only tell me why can't I do this thing? Like I will train on 25,000 images, and from those 25,000 images I will basically say keep 20% of the images for my validation set. From those only. Why can't I do this thing? 100
So you
zeros
can't
and
do
bring
that.
in 100 new images. Bring in 100 new images? From where will I bring 100 new? I didn't understand your point. Okay, first answer this question, Harshit Gupta.
Yes, sir. So you can do that. So like that.
Why?
So no. So what I'm trying to say is that instead you can do an 80, 10, and 10 split then, in which like you can keep 80 images for like training, 10 images for validation, other 10 images for testing purposes.
No. I am not talking about testing. Why? Because testing Kaggle will provide me. Don't need to worry about that.
Okay,
I am just asking you one question. To everyone, the question is like, why can't I do this thing? I will train my model on all the images, on all 25,000 images, and I will use 20% of those images as my validation to be on new data. Because
that because sir, that means that
Sir,
because
these images were already used for training the data, so they will generate
Abhishek.
less error.
Yeah, correct. So that way it will be just a rote learning, right? Yeah, correct. If we use old images for validation, then there might be an edge case that will fail. No, so the answer Abhishek give and the previous guy give was correct. That if I will use same images for the validation, so my model can easily rote na. Like we want to train a smart brain. We don't need to train a dumb brain who just wrote the images. Because if you want to rote the images, do one thing. Go write a code of if else. Like if this image, then output dog. Just write 25,000 line of code and you are done. So that is not the thing. We want to train a logical model. So that way we cannot like validate on those set of images. So that is the reason.
Sir, I still have a question on those parameters.
Yeah.
So, suppose the model right now is using some parameters, and after training, while testing we are getting say bad values. It's not showing a good result. And you said you changed the parameters. So what
No.
exactly will you change and where would you change it?
No, if it is not giving a good performance on the test data set, it means that there is some problem with my model. It should give logically, because validation was a new data set. So actually your point is very nice. I will tell you. So that way only we need a new test data set also, because validation data also our model saw. Maybe he don't train on those images, but he saw those images also to change the parameters. As what is your name? Abhinav is saying. As Abhinav is saying, our model is using validation images also to change his parameters. So I cannot use validation set directly as the test set. So his question is very nice. So that way I need to make a new test set. So, but yeah, there is no solution to your point, because obviously there should not be, because we want to, at the end, why there is a test data set, because we want to see if our model is like truly learning or not. That way.
Okay. Okay.
Yeah, Abhishek is right. But the reason is simply that we need some, like if you are say training on say 1 lakh images, and if you are giving just 100 images on validation, it will not make much sense na. So you need to give just a ratio. You, if you like, it's just your wish, you can take 85-15 also, that way. Cool. So this was nice. Yeah, let us move forward. So now what I'm doing right now is I am basically cutting down this table to two portions. First 20% and other 80%. 80% I will keep for the training, and 20% for the validation. So I've taken two variables here: train underscore df, that is training data frame, and val underscore df. And here is a function, there is a use of function train test split. Let me show you how I imported it. See, here I imported it from sklearn dot model selection. I imported train test split. What it does is it splits your data frame, your table, into two parts. What is the ratio? You need to mention the ratio here. Test size is equal to 0.2. What it means is that 20% keep it for the validation and rest for the training purpose. First argument is df, my original table. Second argument is test size, which is the ratio in which you need to divide. And what is this random state now? Okay, I will tell. I will not ask the question. So random state we have just mentioned. Why? Because we need to randomly divide that data frame. Why? Because see, if the Kaggle would have provided the data in the order, say in the 25,000 images, say first 12,000 images are of dog, and second 13,000 images are of a cat. Cool. And if you just took last 20% of the images for your validation set and first 80% of the images for your training set, then in your validation set you only have the cat images. It is not a good thing, na. It should also have a mixture of full data set. That's why I am randomly basically choosing the rows from my data frame, from my table, and taking random 20% of the rows. So this is the thing. Okay, this is all not needed. Let me comment this out. Why we
Sir, but what is 42? What is that scale?
42.
What is the maximum
that
randomization?
is just a random number. Nothing. Say you can say a seed. Nothing. It is like, don't worry about that thing. You can specify any number. We should take different type of. Okay, sorry. We should different type of images for training, matlab, isn't it? What do you mean by different type? Yeah, not of the same. No, there are not the same type of images. They are of dogs and they are of cat, but those are not the images of same dog, na. So what do you mean by different type? My problem is for dog versus cat classification, so I will take dog and cat randomly picking of images. Can you unmute? Like, I'm not able to understand what you mean. This randomly picking image. So no, they provided a data set in there which there are a lot of images of dog and lot of images of cat. So they are already random, na. So and if they are in order, that way I am mentioning an argument of random state, so that I don't choose blatantly. I just don't choose first 80% and last 20% of the rows. How do you pick? Oh, you don't need to do anything, because Python already provide you a function. So what Python will take care of everything. Now why to understand this thing? What you can do is just pick 20% of the rows, put it in some other table, and keep rest 80% in my first table. Right, Saras? Okay, Lavanya. Okay, yeah. Cool. So this was my split. So let me run this cell. These two lines are not needed, so just don't worry about this thing. Maybe. So now what I'm going to do here? Now I have two tables. Sorry. Yeah. Now I have two tables. One table of training and one table of validation. Let me see the size. Okay. Let me comment this out first. Don't get confused with this. See, what is the size? 20,000. 80% of 25,000 is obviously your 20,000. So that way. And what is the size of my validation? It is 5,000. Cool. Yes, sir. Yeah. Basically, as random. Yeah. Yeah, you can say that. Yeah, cool. So now one thing is now there is one more very important library. Like just like say my favorite library is like Seaborn. The library name is Seaborn. See here I have imported it. Seaborn, import Seaborn as SNS. So it helps us to basically plot, like make various plots. So what plot I'm going to make right now is, as I gave you a point. So logically, as you guys can understand, because you guys already answered a lot of questions, you guys can understand, right, that the distribution of dogs and cats in my training and distribution of dogs and cats in my validation should be approximately same. Like it should not be like that my validation contains only one image of dog and 1,000 images of cat, and my training contains say basically 2,000 images of dog and only one image of cat. So my distribution should be equal logically. So what I will do is, see, in DF this was the category, so I can make the plots how many number in this category column are 0 and how many number are 1. So for this I am going to use this SNS thing. So the thing is sns.count.traindf.category. So traindf.category is mentioning a column, and sns.count means the count. Uh, sorry, just make a plot of count of different things in this. So let me make a plot. See what it is saying: 0, 1. 1 was for dog. This is a bar plot, and approximately it is saying 10,000 images are of 0 category and 10,000 of this 1 category. Same way we can plot for validation. This way, it is saying 2,500 approximately for dog, cat, and for dog. Obviously, it will not be same every time. This is a simple problem of Kaggle, so it is same. But obviously, it cannot be same. While making the dataset, who cares that I will click equal images of dog and cat? It can vary somehow, but the thing is that in training, in this graph and this graph should look approximately same. There should not be much variance. Should be uniformly distributed. Yeah, it is uniformly distributed. So anyone, is it not clear that why the distribution of training and validation data frame should be equal? Why these two should look approximately equal, not exactly equal, approximately? Because obviously we are also taking randomly. So is this point clear? Because now we will be moving forward to image generator thing, which is again a very important thing. Understood, sir. Okay. Okay, now let's move to image generator. Okay. So now we have prepared the data. Now data thing is almost finished, not entirely, because there is one more very important point. So see, mostly in our computer vision problems, like they have provided you some data. At most of the time, the neural network, the black box which I told you, is a highly complex mathematical function. It needs a large number of images to train properly, because your brain is a little, you can say your brain is smarter than machine learning models, because obviously we are writing the code. So our brain is much smarter than these algorithms. So this, like for example, if I will show you say 100 images of dog and 100 images of cat, I can guarantee that most of the humans will easily recognize who is dog, who is cat on a new set of images. But algorithm will not work this way. Algorithms need a lot of data, but there is a limit to make the data also, na? Like how many images you can click of dogs? You cannot click infinite images. So there is a technique. By which, if you have 25,000 images, you can make 50,000 images from those 25,000 images. There is a very cool technique. That technique is known as image augmentation. What is the meaning of image augmentation? See, if I gave you an image of a dog, and if I say you guys that if I horizontally flip that image, then also it would represent dog, right? If I horizontally flip that image, obviously if I vertically flip, then it will not look, it will be dog, but like it should like not be the apt way to take the image. But if I just horizontally split, then it will also be dog. So there are various techniques which we can apply to basically replicate these 25,000 images to a large number of images. Can we create an image of a dog that doesn't actually? We can obviously create an image. There are a lot of methods for these things. Like there are many things like GAN and all that stuff, GNNs. But yeah, no, out of scope for today's workshop. And also that is not very simple. So, but yeah, we can create humans also. You might have seen some website. There is a website that this human does not exist. Yeah, see, there is a website. You open this website, there is person. Yeah. So this is an image created from a machine learning model. This is not a real person. So yeah, see, imagined by GAN. So yeah. So yeah, where was I? Yeah, I was saying, so there are a lot of image augmentation things. What are other image augmentation things? Like maybe changing the lighting of your image, like maybe making the lighting dim, or maybe say randomly shifting the position of your images. Say your dog is present in the corner, make it to the middle. Why it will help? It will prevent my model from rote learning. If you will give him just a set of images, he might try to basically say क्या कहते हैं, just wrote on those set of images. But see, if 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 at every iteration I gave him a new version of an image, say for example there is an image of a person, any person. If I fed those images to model many times, so it will try to basically wrote that image. But if I will try to give a little variation of that image, maybe by horizontally splitting, adding some noise to that image, adding some, say, zooming that image, zooming in that image, or adding some lightning, darkening the image, applying various technique, then it will prevent my model to rote from that image, and it will basically convince my model to understand the meaning of the image, logically understand what is the meaning, instead of just rote learning on that image. Is this point clear? So this is an artificial way to replicate my data, and this is very important. Yeah, additional effects. Yeah, correct. Oh, you deleted. Yeah. So is this point clear? If it is not clear to anyone, just ask, because now I'm going to show you the code for this. Code is very simple because we are going to use libraries only. We are not going to write our own code, so that's why. Cool. I am moving forward. So there is one more thing, not not very important. You can work without this also. Image generators. What are image generators? So I told you that my CNN blocks and my neural network are black box to which you feed the image. Now there is a question which arises in your mind. Like right now you don't know how to train model. So how will you feed the image? So there is a very easy way to do that. This way is known as image generators. You can do without that also, but there is a very easy way. Okay, just forget about this cell. I will tell you what this cell is. It is not of a much role. I will tell you why I have written it here. So see, how we take image generator, train data gen is equal to image data generator. Here I am put it image data generator here. Where it is? Yeah, here it is in the last line. So generator is just a thing to basically feed the images to the model, a feeder or anything you can say. So not anything, not much logical thing. Here it is image generator, and here you can basically mention all the augmentations you want to do. What I've done, zoom range is equal to 0.2, shear range is equal to 0.2, width shift range, height shift range, horizontal flip is equal to true. So these are the set of augmentation which I want to apply. Basically zoom by some value, 0.2 is the value of zoom, shift by some value, horizontally flip. Now this is not a fixed thing. This may vary from say problem statement to problem statement. Like in this problem, I cannot apply a vertical flip, because if there is a vertical flipped image of a dog, that doesn't make much sense, right? So this vary from a problem to problem, right? So here, this way I mentioned the augmentation things. Now see, this function is very important. Train generator is equal to train underscore data gen dot flow from data frame. So what is this flow from data frame? We made the data frame already, na? Having files name and zeros or one. So what this function is very useful for us guys, because we believe in libraries. We don't want to write lengthy codes. So what this function will do, it will take the data frame, the training data frame, and basically you have mentioned the file name, na? It will read the file name, load that file name, and pass it to your model. So you don't need to do anything. Otherwise it would be a worry, na, how to read the image from a given path, how to feed it to black box. So this generator will do everything for you. You need to just provide him the data frame and the data path. What is the data path? Like my data frame only contained the file names. So those file names are contained in some folder, right? In our case, it was contained in data folder here. Those were contained. So I need to mention the data frame. I need to mention directory in which those files are stored. I need to mention that X column is the file name and Y column is category. Why? Because Y is my output and X is my input. Images are my input and what do you say? Labels are my output. Color mode is equal to RGB because RGB because my images are RGB images and not grayscale. I will tell you what these two things are. Class mode binary means only 0, 1. There are two labels. If there are more than two labels, say you need to classify dogs, cats, and say rabbit, then you can use class mode as what you say by multi class that way. What is TensorFlow used for? Okay, I will tell you, sir. I can understand this code, okay, but it's quite easy. What is TensorFlow used for? Because basically TensorFlow is a library, most frequently used library for this machine learning thing. Why used so widely? Because it provides a lot of functions and we don't need to write anything. Okay, I will explain this code again. See, there are two parts of creating a data generator. Are we inputting DF to generate? Yeah. We are basically we are not inputting kind of what we are doing. See, let us try to understand logically. You have a table. In that table, you have file names of each file and you have the label of each file, right? And those files are stored in my folder. Say any folder, data folder, any folder. You can store it in any folder. So now to input those images to a black box, what steps do you need to do? Nikhil, can you unmute and tell me what steps I need to do to feed images to my data that black box? I'm not asking code wise, just randomly. What steps you think you need to do?
So basically, like a images, like a train data set, you have to input or to the model and then it will split the name like. It will split the name of the or the label from the data set.
No, I already split it at I already prepared a data frame for this purpose also. That I already split it at now you have a table in which you have a file names and corresponding label. So let me tell. So what I meant is I have a table which has file names and corresponding label. I have all the images stored in my data folder. Now to input those images to my say a model, a black box, just like in layman terms, what I can do is I can loop over my table, take a row, get the file name, read that file from my folder, feed that file to our basically model, and tell my model, hey, this is the file. I have read the file using my Python functions, and this is the label for this file. Go and learn these things. Am I right? Are you clear with this?
Yes. Got it.
So these are a series of steps which I need to do. But why should I do if they are already inbuilt? So this is where trained generator helps me. It will read automatically. You don't need to worry. Just give him the data frame containing your file names and corresponding label. Mention that X column is file name and Y column is category. X means your input and Y means your output. Tell him the data folder path. Tell him the data frame, and I will tell you these two things. Just 1 minute. And tell him that images are RGB or not, and it will go. It is good to go. And here mention all the augmentation you want to do. So are you clear with this thing? Then I will explain you these two things.
Yes.
Yeah, everyone, is it clear? Okay.
So, hello.
Yeah.
Below this the train generator, what is this train data generator?
Where train data generator? Where you mean?
In the code.
No, this train data gen.
Train data gen, yeah.
This is just a random variable. I am not using it after this, so it is just for this thing basically. A kind of variable, you can take anything.
Okay.
Yeah, not of much, but just a variable. It is simple variable. Just a loader for basically augmentation. So how it will work, I will tell you the working of this also. I have prepared code for that also. I will tell you that this. Just remind me if I forgot. Yeah. So what I was telling. Yeah. So. Yeah, I was asking if this is clear for everyone, right? Then I will explain you what are the this image size. Cool, I am moving forward. So now basically your model is a kind of dumb. He will, if you will, so model is a mathematical thing, right? So if you give him an image of say dimension 400 cross 600, he will take the image. You will basically code in your input in your black box. You will specify that I will give you input of size this. But if your other images of size say 800 cross 1000, then your model will give an error that I only can accept the input. Like for example, in your C++ code, when you do coding, you take an input C in N, but there is an input format, right? If you give some different input format, then obviously your code will give an error. So same way it is here. Your ML model, your black box, will take input in some, basically you need to specify some input sizes. So what we do in ML, we basically resize the image to some standard size. Like for this problem, I have taken the size C. Here in constants, I have taken image height 128 and image width also as 128. Image channel 3 means your image is RGB. In grayscale image, your channel are 1. You already know that. So that way I am mentioning here the target size. That way. So this is the so what this generator will automatically do this thing. What he will do is he will basically resize each image to this size. So that way, and resizing will not create much issues because the features are also stored in the image right now also. So that is not a much problem. So now let us understand what is this batch size. Okay, I will tell you this batch size afterwards with the box, so that way it will be more clearer. Just yeah, I will not forget to explain this. Now let me tell you one more thing. If I run this code, it is saying found 20,000 validated image file names belonging to two classes. Two classes means there are two distinct labels. Now there is val generator. Now there is one important thing. In val generator, we are not applying this augmentation. Rest full code is same except this val df obviously. We are not applying these augmentations. Why we are not applying? Because we want to test on real data set. Like what is the performance on the real data set, not on the augmented one. We need augmentation because we need to train our model that way. Na? So in validation, we don't basically apply those augmentation because we need to test our model on a real time images, not on a basically augmented images, because that way we can get a more more insightful results, like how my model is performing, right? So that way I have not basically uh, applied augmentation here, but I have applied this one rescale thing. Can anyone tell me what is this rescale thing?
Changes the size of image.
Changes? No, rescale. It is saying rescale, not resize. Anyone can answer, maybe in chat or anything. Okay, no one. Okay, no issues. So basically, pixel values RGB. Yeah, kind of. So what it does is basically your image RGB images, as you already know, your pixel value of RGB images are from 0 to 255, right? So that are the pixel values of your image. So in ML models, what we do basically is divide that number by 255. Basically rescaling that 0 to 255 range to 0 to 1 range. Why we are doing that? The reason being to just reduce the input size, because so that our model can learn things faster, because anyways it is not going to change anything now. Because when I am rescaling some range from 0 to 255, if say there was let us say there was an image of say like first half of the image was of red color and second half of was blue color, right? So red and blue color might have some RGB values, some any RGB values. So if I rescale them from 0 to 1 range, they will map to some values, but they will not be the same values, right? They will just we are just performing rescaling, not entirely changing the values. So the meaning, the insight in that RGB value still remains the same, because we are just rescaling to a new range. Are we changing resolution? No, not like uh, we are not changing the resolution here, because it when we are resizing, then we are changing the resolution. Na? Right now we are just say mapping the like 0 to 255 range to 0 to 1 range, obviously in decimal points. The reason being just it is easier to feed to the model, because if you feed large number to the model, then it doesn't make much sense. So that is just a standard step, right? Then what rescaling means? Rescaling, I told you na, that it is basically your RGB pixel values are from 0 to 255. It is just scaling that 0 to 255 number to 0 to 1. Just say divided by 255. For example, just take let us take an example. One number is 0, second number is 255 by 2, which is 120, say 127.5, and the last number is my 255. If I convert these three numbers from my 0 to 1 range, my numbers would be 0, 0.5 and 1, right? Is it like bijective map? Yes. How long this workshop will be? Actually, it was meant to be till 2, but it is taking some time to explain the things from basics. So I guess it will take at least up to 3. Like, I am willing to take till 3, but yeah, it's your wish. So yeah. Okay. If this is clear, I am moving forward on to the working of image generator. Like just a recap of this thing. This is just like we are just using functions. So how this works? What this is, say, a kind of a loop. It will load one image from my data frame, read that image from my the folder which I mentioned here. The folder name is data path. Apply some random augmentation. It will not apply these all things. Oh, I forgot to maybe mention this thing. Like here you have mentioned 1, 2, 3, 4, 5, 6. 6 augmentation you have mentioned. It will randomly apply some augmentation, maybe anything, and just give that image to my model. To give you the proof of this thing, I've shown. Let me show you the working of generator. Here I have just loaded randomly some images and just shown them. Let me run this code. See, what it did is it take an image from my data frame, it loaded and applied various augmentations. See, here the dog is facing left, here he is facing right. So horizontal flip is applied. Here some reshaping is applied. I have moved it to a left. Then here some zoom in is applied, I guess. Then here there is an issue because it is hiding the face of the dog. But yeah, we need to adjust our augmentation according to this. This you can see there is some little variations in this, say, for 16 images, just little variations. So this way I have created 16 images from a single image. Are you getting this point?
Sir, so are we increasing our training size or test size?
Very nice question. Very nice question. I should have told that. Very nice question. So see, logically we are not increasing the size. Why we are not increasing the size? See, I have applied a lot of augmentations. You can apply hundreds of augmentation also. But then if you need to store those images in your collab notebook, it will say memory limit. So why you want to store that image? What you can do is at every time you want to feed that image to your model, just apply some augmentation, load it in your RAM, to be in technical terms, and basically feed it to the model and just remove it from the RAM. You don't need to save it, na? Are you getting my point?
Yeah.
Getting my point, right?
Yeah.
Yeah, it was a nice question, right? Cool. So yeah, Yash, you are saying that no, I am not applying the rescaling here. That's why, na. See, I have loaded example generator here. I have prepared an additional example generator to show you the images in RGB colors. That's why I have not applied the rescaling thing. But it was a nice question. I'm glad that you noticed this. Cool, Yash. Okay, just please put in the chat if till now everything is clear, because now we will be moving to model running thing.
Sir, one more thing.
Mm-hmm.
By augmentation, we are also increasing our data sets, increasing the number of images in the data set.
No. For example, see, let me tell you. Just take a simple example. Say there are only 2 images in your data set. One image of dog, one image of your cat. So in your memory, only 2 images are stored. But as you train model in various iterations. If you know about epochs, I will explain you. If you know about iterations, I will train model in various iterations. So what this code is doing is, before first iteration, it will load image, apply some augmentation, feed it to model, come back, apply some random augmentation, go to the model, feed, come back. So it is virtually increasing the size of my dataset, but not actually, because in memory I am not basically saving that images. Na? That's why it's known as image augmentation. That increases the size, but we are not storing to a disk because of memory limit things, right?
Yes, now got it. Yeah.
Yeah. Obviously, if you want to save, you can, but here we are not doing. Okay. Now we will be moving to model training, but just give me 2 minutes. I need to attend one call. I'm coming in 2 minutes, right? I will put the code screen here. Or you have the notebooks already. So just see the code. If you have any doubts, then we will be moving to model training. I'm coming in just 2 minutes. Yeah. Yeah. Sorry for that. So let us move forward. Do you have any doubts? So actually, right now only it is 1:40 and session was supposed to be till 2. But yeah, as it is taking some time to answer the doubts and explaining from basics, so like we will most probably extend the session till 3. So I hope it is not an issue for you guys. So is there any doubt? Okay, then I'm moving forward. Now we have loaded the data. You understand the data frame. You understand what is our data. You understand why we need various splits. You understand what are the augmentation and all stuff. You understand obviously. So now let's move on to model training. Now we are going to train one model. So now let me tell you one thing. So this was the black box which I am talking from the start of the session. But as this is a black box, so I don't want to code this. So we will just use see, there is a concept of transfer learning in machine learning. What is the transfer learning? See, they, like for example, yeah, there is a very famous problem of ImageNet. Like there is a global challenge of ImageNet each year. So what is that problem? There are a lot of right now we are just training dogs versus cat, right? So there are a lot of classes in those images, like say aeroplane, ball, anything, any number of objects or anything additional, also maybe animals or something. So okay, one second, sir, please zoom out your screen. Okay, sorry. I hope it is clear now. Else tell me. Yeah. So okay, yeah. So what happens is for those we don't want to write exact details, exact mathematical expression of those model, right? Because we don't know exact math. We want to treat it as a black box. So there is one option known as transfer learning. What it means is we can use the model trained by some other user on some other problem to our problem. Now, how can this happen? Let me tell you. For example, a model is trained on, say, to classify images of various objects, say ball, aeroplane, car, bike, something of that kind. A model is trained on that type of data set to classify those images. So how can I use that to my data set? Oh, sorry, my problem for my data set things. So what I can do is, like I told you already, that initial layers of the model basically tries to understand the meaning of my what you say meaning of the images. Like there are lines in the images, there are eyes in the images, there are difference of color in the images, and this thing, initial layer of model, there are a lot of layers in my model na. For example, you can easy to understand easily, like, though this is not a true thing, but I'm just giving an example. You can say, like, if there is an equation, say ax cube plus bx square plus cx is equal to d. So you can say initial terms, like higher power terms, say x cube. This is not a true example, this is just a wrong example, just but an easier reference to give. So that's why I'm giving x cube terms learns the features from the images. Now I feed those features to my x squared layer. Now my x squared learns some other thing from those images. So sorry, from those features. Now comes the x layer, the cx term. My that term learns, say, uh, how to label those images to this data set, to dogs versus cat data set, or to objects data set. So what I can do is I can take the first two terms from any other problem and use those as it is and apply third term on my own. Okay, I will take your doubts, but let's first see why I want to do this. The reason being, see, these ML models are very large. Like in size, they have millions, trillions of parameters. I already told you what are the parameters, and a lot of layers. So that's why I already told that neural networks are highly complex functions. So if you want to train it from the basics, now it will take a lot of time on your machine, and you don't have that computation power on your, at least on your local machine. And on Google Colab also, it provides some limit of GPU. So you can train it on your own, and it will take like many days also to train properly, because it is machine and it will take a lot of time. So what we can do for this aid is, we can just take the training, like for example, for first two layers someone has set the parameters already. What now I can do is I can just take those parameters as it is, apply those parameters to my problem, and just start training na. If I have applied the same parameters, because that model already spent 2-3 days to go get those parameters. Now why to spend my 2-3 days again? I can just take his parameters and apply it on my own, my own problem statement. And the last layer I obviously need to take on my own. Why? Because my problem statement is not same as his problem statement. His problem statement was for object classification of, say, 10 categories, but my problem statement is a binary classification of 2 categories. So what I can do is I will take A and B from his parameters, and then I will train my model. So that way it will take less time to train my full model and less computational power. Is this thing clear? The transfer learning concept, because this is the majorly used thing every time, because no one writes his own code. Everyone use the, like, someone else weights and all that stuff. The model is already trained. So on these problems, these big problems, like ImageNet is a global challenge. Various companies like Google, DeepMind, and all that companies basically test, like, there is a challenge. So they submit their models, and whoever gets the highest score get the prize. So they would write the code from scratch. But we will not write now. We are not that like sufficient. We are right now beginners also. So that's way. So is this concept of transfer learning clear? Then I will move forward that how to apply this and all stuff. Anyone? If this is not clear, then also please say.
Sir,
Yes.
can you explain by example like how transfer learning will happen for a image related to dog or cat, like that?
Yeah. I gave that example only. So let me take an example. For example, you have a model. Like for example, Google trained a model because they have highly computation power, high resources, but we don't have those resources, right? And we also don't have that time. Na? They train model for many days. For example, they train model for which has 5 type of images, say car, bike, ball, aeroplane, and animal, anything. Just I'm taking randomly. Just they trained a model. So I already told you by an example, ax cube plus bx square plus cx is equal to d. So ax cube plus bx square, this whole blocks learns features from the images and some things from the images. Do companies allow the engineers to copy and paste content codes instead of writing codes? I will tell you. So first two layer learn these type of things, and third layer basically is specific to the problem statement. For example, if their problem statement is of 5 categories, they will obviously give output from those categories. But first two layers are just learning how to interpret the images. Like for example, your eyes are already trained to understand some scene, so we need to train our model also to understand the images, right? To understand the edges, understand the colors in those images. So that way, those first two layers they have already trained on high powered GPUs and all stuff. So we can use first two layers of them and train and put third layer of our own and train full model again. So how it will help, because they have already trained first two layers themselves, so we can get the parameters, the A and B parameters from them, and we need to not like train for the time for which they trained, right?
Yeah. Okay. So like every layer is a separate neural network. Can I say that?
No. Not a separate neural network. In a neural network, there are separate layers.
Okay. So each layer will be may have activation functions or not, like that.
Yeah, each layer will have their own activation function and everything.
Yeah. Okay.
Yeah, Rajat's question: can you reusing this? No, it will not lower. It will higher your accuracy. Why? Because Google already trained those models on highly computational power, and with also they are applying their own neural network. Now that also I said, na, like we don't know the black box, the match inside, but they don't know the match. So they applied their own networks. They experimented which network, how it will work, what match. They applied match also, and come up with an algorithm how to train model, like how to get those weights efficiently and all that stuff and most accurately. So we are using their resources, so obviously it will not lower your accuracy. What if the model was overfit? No, yeah, they will obviously not provide the overfit model. No, it is a standard library, so why will they provide an overfit model?
So the initial layers will be used for learning, and other layers will be used for
Yeah, so
what?
initial set of layers are not specific to that problem. They are specific to understand features from the images. Actually, to understand the features from the images is not a very simple task. It is complex task. It learns features step by step. If you want, I will show you at the end of this session. There is some image. Right now, obviously, we have less time. So it learns step by step. So that is the work of initial layer, and last layer is specific to our model. Cool. Yeah. So now let's move forward. There is a very famous model, this efficient net, released by Google only, I guess. I am not sure. There are 7 types of model they have released: B1 B till B7. I guess from B0 to B7 there are total 8. I am not sure. So we can use their model only. So how to take? See, here it is a function to build the model. First layer I have taken sequential. What it means is I will sequentially add layers, say block to block. I'm adding, putting a block on the bottom, then adding a block on top this way. So that way sequential. Then this is just defining. Now I am adding those blocks. See, add. First block is my tf.keras.application efficientnet b5. EfficientNet B5 is the name of that Google's model. Weights is equal to ImageNet. Actually, this ImageNet is a very famous problem. You can search on net also. So weights is equal to ImageNet means, uh, see, we can do 2 options. One we can do is we can take their architecture of Google. Other option is we can take the weights also of Google. So right now we are taking architecture obviously because we are adding that layer, and we are taking weights also because we know that Google has already basically trained the model. So we will use their weights. Right now we have include top is equal to false. It means that the last layer would be mine because my problem is not same as Google's problem. Google's problem was some other and my some other. So include top is equal to false means don't include their top layer. The last layer you can say. This input shape I already tell you. We need to specify the input parameter, right? So this is the input shape. So this is the thing. So see, this is just one line of transfer learning. Now, if you want to say train some other model, what you need to do, you just need to erase this and write some other name. Say Inception. Inception Resonate V2 is also maybe I don't know. It is a Google model or any organization's model. You can use that. So you need to just change this name, and you can run a lot of models. See how easy it is. You don't need to do anything because these 3 layers are already same. I will tell you why. So is this transfer layer specific? Like, let me write. See, So this layer is specific to transfer learning. Are you clear with this layer? See, let me repeat. Efficient is mentioning the name of the model which I want to copy. Weights means that I want to use their parameters also, not only their architecture. Include top means last layer would be mine, not them. Or an input shape is obviously clear. So if this is clear, then I will move forward.
Can you explain include top again?
Yeah, include top means that do we want to use their last layer, or we want to put our last layer? Because it can happen that you want to say your task is same as the efficient task, the same task of Google. So you will include the top layer of them only. Now, why would you write on your own? But right now we need to write our own, right?
Yeah, okay.
So include top is equal to false means that don't include their topmost layer. I will write my own topmost layer. You don't do that thing. I will include myself. I will write myself, right?
Yes, yes.
Yeah. So let us move. Okay, sorry. Yeah. So, oh, is it clear to someone else, like others also? Like you're not typing in the chat. I don't want to take anyone's name, so maybe say, Srinath, is it clear to you?
Yes, sir.
Cool. Yeah. So do everyone ask any doubts if you have. So yeah. So now this was my transfer learning thing. So I told you now how easy it is to change the model. You just need to change this name. Just change this name and everything is good to go. Because this tf.keras.application, tf means TensorFlow. Let me show you also. I've imported TensorFlow as tf. So it means TensorFlow. So TensorFlow has all the models, so you don't need to worry about this. Now I am adding my own layers at the top. Let us see this. 1 second. Yeah. So first layer is global average pooling 2D. Actually, don't. If you want to go into deep, you can go. But I would recommend don't go into deep. What this does is it basically flattens. Sorry, not flattens. Basically decreases the size. Like for example, the output of this layer. Every layer is independent, and every layer will give its output some two other basically layers. See the architecture this way. Let us see this thing. It will be more clear. I have plotted the architecture. See, first two layers are of efficient net. See, here it is written the size. Input size is 128, 128, 3. 128, if you remember, was our image height as we defined earlier. So this layer pre-processed our input images and converted the images to 4 cross 4 cross 2048, right? The size is 4 cross 4 cross 2048, a 3D matrix, you can say. Now comes my global average pooling 2D layer. It basically flattens my input. My input was initially a 3D matrix. It flattens it to 2048. How it flattens? It basically, actually, I don't want to go into detail, but to tell briefly, there is an image, right? So what it will do is it will take average of blocks of that image. It will take blocks of some size, like maybe say 4 blocks. 4 blocks have their own values, pixel values, and it will take the average of them values. Why I am doing this is because we need to reduce the size to at last, because at last we want to feed our basically input to neural network, and neural network accepts straight and flattened vector. So at last we want to convert our image, which was an image originally, to a 1D vector. So that's why we need this global average pooling and dropout. So sorry, not dropout dense. Dropout is an additional thing. I will tell you that also why. So global average pooling does this averaging thing. Actually, there is one more layer known as global max pooling. So instead of taking average of blocks, it takes max of those blocks. But average is more useful. Why? Because see, what average will do, see, there might be noises in your image. You obviously know that if you click some image, there may be some noises, right? So, but you don't want to like accumulate those noises in your input. So by taking the average, you can remove that noise easily. So that's why this layer is very useful. Then comes our dense layer. So what dense layer does is, dense layer, it is just a neural network. See, I told you na at the start in the image task, there are two types of thing: convolutional thing and neural network thing. So dense layer you can treat as a neural network. So to that neural network, you feed some input and it will give you an output, right? So see, there are two dense layer here. One dense layer convert 2048 to 5, and other dense layer converts 5 to 1. Why I am converting to 1? What is my end output? My end output is either 0 or 1. That my image is either of dog or of cat. So that's why my end output is size of my end output is one, just one. So 1 second. Yeah. So how I mentioned it here. See, I added one layer, tf.keras.layers, global average pooling. You don't need to write the code inside global average pooling. You just can write this. And as we are adding just layers, so it will automatically give its output to this layer. Then my layer comes dropout. I will explain you what dropout is. Just forget about this right now. Then I'm including a dense layer. Then at last I'm including one basically layer whose size is one and activation is sigmoid. Sigmoid activation is used for say this binary tasks because my output size is one only, either 0 or 1. I know this is a tough task because it includes understanding of some technical terms. So dropout I will explain you afterwards. Rest, is it clear? Or let me explain again. Let me give a recap again. So firstly, I use the transfer learning model. Then I need to add my own layers. So what global average pooling does is it removes noise from your images. So that is very important thing. It removes the noise from your images by taking the average, and this way it is flattening my image. Then I have dropout, which I will explain you right now. Then my dense layer are basically neural network, highly like the mathematical functions. I will not write. I will just add the layer, and you are good to go. This is the first layer, and this is the second. The last layer is very useful because if you want to run this code for your specific problem, you need to change only this last layer. The size right now is 1 because for our problem was a binary classification and we need just one output, and activation sigmoid is used for these binary tasks. So this was the thing. Except dropout, are the other things clear? Just the logic, like why there is a need. Obviously we are not going into deep like what exactly pooling layer is doing, what exactly dense layer is doing, but is the logic clear, the concept? Please reply in the chat, because else why we have used ReLU before sigmoid. Yeah, I will tell you. Just 1 minute. Any other doubts? If it is clear, then please reply in the chat. What was dense for? Dense is basically the neural network. I told you in the starting na, that for image task there are two blocks. First is okay. I will explain again. Cool. I will explain again. Cool. So see, firstly, what I did is I added my transfer learning model, the model which I got from the internet, the Vision net. The output of that model was say this. The size was 4x4x2048. Now I need to remove noise from my image. So this is a compulsory layer that average pooling. It will average the pixel values and remove the noise. Just understand what it is doing because we cannot go into the deep right now. But if you want, I have added the sources in the slide so you can check that. Then dropout I will explain. Dense layer is the neural network. I told you already na that computer vision problem have two components. First component being the like the convolutional part, and then being the neural network part. So that way dense layer does this task. And the last layer is just to just to mention my problem specific size, because at the last anyways I need an output of size 1 only, that way. What if dog images have one background? You can. Oh yeah, good question. Good question. So see, logically, what should it learn? Logically, like we are human being, we will learn that that is a background and this is the dog. That is the reason that why machine learning model needs a lot of images. See, if there are 100 images, there are background in the 100 images and there are dog. So the shape of dog would be more or less the same. Not exact same, but more or less. That at least you can identify that this is the dog. But background would not be the same. So machine learning model should logically it should learn. Na? If it is a like smart guy, it should learn that in these images, if you are saying that these 100 images are of a dog, then this background is not contributing to the dog. This dog component in this image is contributing to the dog. Right, Rajat? It was a nice question. To prove this also, I will show you the proof of this also in my second code. Cool. So any other doubt except this ReLU one, I will tell this. If it is clear, then please reply yes. At least I should know that you are getting or not. Okay. Okay, many people are not. Okay, many guys are don't want to like push. Okay, now answering the Nikhil's question, why we need ReLU before sigmoid? So basically, see, sigmoid is only for the thing of binary classification. When we need to when we need to convert a highly sized input to one, then we need sigmoid. Basically, sigmoid does the task of converting your input to one sized input, just size of one. Like there might be some logic behind the sigmoid, na. Basically, it is a mathematical function of some sort, e to the power of x divided by 1 to the something of that kind. So it is a mathematical function. The reason why I just know the reason why I use sigmoid, because I want an output of size 1. That's why I have used sigmoid. Now comes the reason then why I have used the ReLU. ReLU is the most important activation function. Like now many guys will ask what is the activation function. In the neural network, in the black box, there is one thing known as activation function. I will not explain it right now because of like time constraint also. But you can understand there is something known as activation, and ReLU, till now ReLU is the most like useful thing. There is a leaky ReLU thing also, that is also good, but ReLU is the mostly used thing. So mostly we will use ReLU. Now your question should be why then we use sigmoid. Reason of using ReLU is that it is very like nice activation. There are very different type of activation. Is basically just a mathematical function, just to say a bijective function which converts this input to that input or that output. Sorry. So so ReLU is a very what do you say very useful thing. Now the question comes, why you applied sigmoid. Reason for applied sigmoid is when you need a input of size 1, then the sigmoid is the most useful thing. So that's why I have applied. Sir, confused what those layers were meaning. Okay, sigmoid will also, I will tell Hardik 1 second. Sigmoid will also cause vanishing gradient or exploding gradient. Yeah, it will cause those problems, right? Yeah, right, Rajat. 1 second. I guess there is some time for this. Maybe I need to run. Okay, let's see if I'm okay. I will see afterwards. Yeah. So okay. Yeah, Rajat, Nikhil got it. Rajat doubt. Yeah, it will cause some problems, but actually, what do you say? There are various like in this. It will not cause much problem because we are using TF keras layers, na. So it automatically takes care of many things. But yeah, your like question was right. Can't I just write dense one activation layer? Oh yeah, nice doubt, nice doubt. No, there is no quiz at the end of the workshop, but there is a special prize, like for which I will announce the criteria at the end of the workshop. Those will be valid to everyone who attended this workshop. But yeah, that there is no quiz as such. The duration of that task will be mostly till tonight, I guess. Yeah, it will be tonight. Yeah. So firstly, answering Trinath's question, that can't I just write dense one activation value? You can write. It will work. It will obviously work. But why we need to write step by step? Actually, I also copied it from the net. But the reason being that when we do step by step, now layer by layer, it learns more things. If you will directly see logically, let us try to understand logically. If you have input, okay, let us see the input size. That way, see, initially the input size was 2048. If I convert 2048 a vector of size 2048 directly to a vector of size 1, can you understand that there would be some problem? There would be some loss here. But if I convert it to 1 step by step, firstly converting it to a lower size, then converting to a 1, then it would be more beneficial. Actually, you cannot answer it directly. It comes only from experimentation only. You need to do some experimentation. Actually, I tried both the models when I did this a lot time ago. So I tried both the models and this was working much nicer. So that's why I did. Reason I'd already told you that it is just an experimentation, that when you are lowering the size step by step, then it is more useful uh, from the case if you are lowering size directly to 1. Trinath, is it clear? And now answering Hardik's doubt, confused about it. Yeah, confused what those layers were meaning. Which layers, Hardik? Can you tell me?
You were talking about the x cube, x square, and then you talked.
Oh, that previous thing. Okay, let me repeat that thing. So I was saying, treat a model as an equation. It is not true. It is just a reference example to understand properly. Ax cube plus bx square plus cx is equal to d. Now I told you that ax cube plus bx square, this part is learning features from my image. It is my this part. So A and B are the parameters of this thing. I can and Google has already trained a model and already told me the parameters, which parameters are good to understand the features from the images. More or less, the features in each image are same. Like what are the main features are lines, boundary change, circles, some kind of feature. Obviously, it are problem specific also, so that is not an issue because we are not fixing those parameters. We are just taking initial parameters and changing them. So this layer represents that ax square plus bx thing. Oh, sorry, ax cube plus bx square things, and this the code for my specific problem represents my last cx thing. Cool, Hardik?
That we were telling that top equal parts, so that C is representing the top, right?
Yeah, great. C is representing the top.
Okay, got it. Thank you.
And do you understand why we can use that A and B? Because it only means how to understand features from those images. So that's why we can use them.
Yeah, it is common in both the.
Yeah, very nice. And also one more thing, as Hardik pointed out. So A and B, we are just taking initial point from Google's efficient model. We are not fixing them. We will train them obviously, but obviously if your initial guess is good, then obviously at the end your accuracy will increase, na. Otherwise, if you made a random initial guess, then it will take a lot of time to reach a good point. But if you have a good initial guess, then it will take less time to reach end point. So, are you getting this point? Hardik, is it clear now?
Yes, sir, it is.
Cool. So now I will tell last thing, what is dropout. So dropout is a very important layer. Now it helps my model. It helps to prevent my model from what you say. It helps to prevent my model from that overfitting. So what dropout does is, actually it is also now again a mathematical thing. In neural network it removes some neurons, like it randomly removes some features so that your model does not overfit on those things. Actually it is tough to explain this easily, like logically, because it is much of a mathematical thing. What it does logically is, in neural network, if you understand, like you don't need to understand, if you understand the neural network concept, so it blocks some neurons in them, and so that your model does not overfit. And coming to this last line, model.compile loss binary cross entropy. So there should be a loss function which I need to reduce while training the model. There should be a parameter, so I need to reduce the loss function. So this is the loss function. You don't need to write it. It is already written by TensorFlow. You just need to mention it in the loss argument. If you have a, say, multi-classification problem, instead of binary cross entropy, you can use categorical cross entropy. Matrix means accuracy, that I want my accuracy to be as high as possible. Optimizer is Adam. Now Adam is also one more mathematical thing, but it is the most used optimizer, so that's why we have also used that. So yeah, and then I've printed the model summary, which is just to like show you like properly. Just let me run this code and I will give a recap. It is building the model, and this line is just to plot the model, not a compulsory line, just to show it like visually. See what it is doing, downloading data from, let us see. It is saying downloading data from storage Google APIs.com KRAS application. So it is downloading the weights of that model which Google trained. Let us open the link. Oh, you see, it is giving me option to download these links. Oh, sorry, these weights, right? So it is downloading the those weights, applying it to the layer, and then running. I already explained this thing, and this is just a model summary. This is not needed. I already printed it. So let me give a quick brief, and then I will move forward. So if you want to understand in terms of black box, just write this line, because our model is sequential. We will add layers layer by layer, then add whichever model you want to use, whichever open source model which you want to use. This is very simple line. If you want to change model, just change the name here and it will work. To see what all models are present, let us quickly see. TensorFlow, Keras, layers, models, SQL. I should write Keras application, sorry. Yeah, see, here also it is coming. Sorry, it is. See, now let's see. See, it is providing us a set of models. See, it is providing DenseNet, VisionNet, Image Utils, Inception v3, MobileNet, ResNet, ResNet 50, VGG, exception, I don't know how to pronounce this. So you can use any of this model. How to use? Just change this name to that. Now this is quite mathematical. You need to understand which model to use when. But yeah, that comes from an experience also. So don't need to worry about that. But I was saying, so this line is very simple. You just need to copy paste this line, and in either problem you just need to change that. And this is, to be honest, this is an experimental thing. No one can answer which of the layers are best. As Trinad asked, why we need this layer. This is a result of an experimentation. I also searched from net when I was a beginner that which layers to add, and I found this useful, so I use this. So this is just a result of an experimentation. You can try this, and then you maybe slightly change, and you can experiment with this. So this is just say an experimentation task. So don't worry much about this. Most of the people, including me also, when I need to train a model, I just copy paste what layers to take from net, because I am also not, I also don't understand properly maths, like how to prove like which layers to put when and all that stuff. Obviously, we cannot understand the math properly. We can understand, but I also don't understand that, and we don't need to. So you can just see from net what are the layers to be useful, and just do that. If you want to understand, maybe say pooling layer functioning, pooling global average, pooling TensorFlow. You can understand properly how it is working. You see, how do I do global? Oh, sorry, it is implementation thing. So yeah, and then at the last step, you need to compile your model. Compiling, you need to mention your loss function. Here it is binary cross entropy, because binary problem. If it is your multi-classification problem, you can do categorical thing, matrix is accuracy, and optimizer atom. This also is obviously a result of experimentation. So yeah, this way now I have built my model. Now there is a thing known as callbacks. I will tell you. Just 1 second. Just say forget about this cell. Just let us run our model, because it will take some time. Till that time, I will explain you callbacks, and then we are over, I guess. Oh no. Cool. So now to train model, we just need to write model. Forget about this. I will tell you what these are. These are basically callbacks. We need to just write model fit, train generator, which contain a training state. Steps per epoch. You cannot, like, if you don't want to mention it, you can just comment it out. It is just your wish. Oh, I didn't explain you epochs and batch size. So yeah. So what are epochs? Epochs means the iteration. Your model trains in iteration wise, like for loop. You apply a for loop, right? Maybe for printing something. So that way your model learns in iteration. In first iteration, it learns something. Then in second iteration, it uses that as an initial guess, then learns, and this way step by step your model learns. So these are known as epochs. And what is my batch size? So now, due to computational power, like to your mathematical model, to your say the model which we like, the mathematical which we consider as black box. One option is feed one input image at a time, take an output, feed an image, take an output this way. But it will take a lot of time, because we have a lot of images, lot of iterations, so it will take a lot of time. So an easier way, less time consuming way is, and also a more accurate way. I will tell you why more accurate way is feeding a number of images at a time. Say a 4D array. Like if your image is a 3D array, I will say input say 32 images at a time. So my input would be a 4D array of size 32 cross जो भी 3D the dimension of my image. So why? So that way it will take less time. It will train on those 32 set of images at once instead of running one by one. So what is the advantage? Let me tell you the advantage. So see, you have 25,000 images to train. Oh, sorry, 20,000. So there may be issues with some of the images. Maybe it can happen that 5 of the images of dogs are not so good, not that good that even humans cannot classify them properly as a dog. You may be in doubt if it is a dog or if it is a say cat. So you can also be in doubt. So if you feed one input image at a time, so it is more prone to learn wrong things. But if you input 32 images at a time, that you will tell your model that, hey model, learn from these 32 set of images. So it will somehow cancel your noise effect. Like, can you understand the logic? Like giving him one noisy image, instead of that giving him 4 correct and one noisy image, total 5 images. That way it will overcome the effect of that noise. So that way there is a need of batch size, which I told you that I will explain afterwards, which I mentioned over here. Batch size. Here I have taken the batch size 32. I defined that in constants, and epochs are my iterations. So it will work in epochs. So epochs, I need to mention how many epochs I want to train. Then there is validation generator, validation step, your wish you want to mention or not. Then this callbacks, which I will explain right now. So just need to run this cell. So see, it has started training the model. Model is started training. So meanwhile the model is training, let me okay, is there any doubt in this thing? Then I will come to the callbacks, which is an advanced thing, like useful to get a good score, good accuracy. Is the model fit thing clear? Any doubt you can ask. Okay, then I'm moving forward. So in callbacks, there are some callbacks. See, one callback is early stopping. I will just give a brief overview because I have already mentioned the syntax. So and I have already like used here also. I will just logically tell you what these things are. So first thing is early stopping. See, how do you know that for how much iteration should you run the model? You don't know, na? Because you are not an expert in machine learning right now. So what you can do is you can just randomly say by an idea you can mention 40 folks. And early stopping is a thing that if your model is not learning much, na, that your loss is not decreasing much, it will stop your model, right? It will stop your model at that moment only, and it will not train after that. How it helps is because you don't know after what time will your model learn properly and at what time should I stop it. So early stopping does it on its own. So this is known as a callback. I mentioned it here. Early stopping, monitor val loss. It will monitor the val loss. At the time when val loss is not decreasing much, it will stop the model, right? Patience is equal to, okay, that is not needed, I have written already. Now one more thing which is very important, like very important, literally you should always apply this in your machine learning problem. It is very useful. Reduce LR on plateau. It means reduce learning rate on plateau. See this image. Now see, consider your machine learning mathematical thing which you consider a black box as this polynomial function. So this is the minimum point of this polynomial function, right? This down point. So this is the minimum loss, and you want the minimum loss and maximum accuracy. So you want to reach here. Consider your starting point as this yellow dot. So if you take, so it moves step by step to the down. If your step size is very small, like here it is written too low, it will move step by step to the down. So the issue here is that it will take a lot of time to come down, right? It will take a lot of time. But if your step size is very high, then your like it will randomly jump here and there. It will randomly jump here and there. So that will also create an issue. So this is the right scenario, just right, not too low and not too high, so that your basically it corrects your step size, what should be your ideal step size, and it automatically correct that step, what should be your ideal step size to go to your minimum point in least time, and yeah, in least time, and based on other conditions also. So basically what this callback does is, at whatever stage your model is, like right now your model is at this point, it will step some step size. When your model is at this point, it will set some step size. Obviously you cannot do that manually, na? So it takes care of himself. So you don't need to understand the mathematical function, like what should be the step size according to your mathematical function you are using, and it will automatically do this for you. I know this is advanced thing, so it might be less clear, but please ask, that way only I can explain. Hardik, is it clear to you? May I,
I'm not getting what those step size mean in those
okay,
catch stop problem.
okay. Just remain unmuted. Let us discuss with you only. So see, your model. This is your polynomial function, and you need to reach this point, right?
Minimum.
Because but you started from this yellow point. Take this first image. Step size means, see, I told you na, iteration, model running epochs, iterations. So step size is like basically you can treat it how much change you should make in your parameter values, right?
After each iteration.
Like basically your model training will give you the new parameter, but you will multiply it with some step size, like how much change you should make, right?
Okay, yeah.
Yeah. So if the step size is very small, it will move to down step by step. But the problem here is it will take a lot of time. Where are we inputting the learning rate? Yeah, I will tell you just 1 minute after this thing. It will come step by step, right? Right, Hardik?
Yes.
Now come to this case. If I take my step size very large, then it will just bounce. The step size is very large, so it will just bounce on this polynomial trajectory and will not reach here soon. Cool.
Yeah.
So my step size should be an ideal step size, so that it should not take much time and it should be like accurate result, not just a random jumping like this. But we cannot set this learning rate on our own, not this step size. So there is a callback known as reduce LR on plateau, which does this on his own. So we just need to write it here and apply this way, right?
Okay, so after each iteration, it changes the learning
Actually,
rate
no,
so that.
not after each iteration, depending upon the conditions. If he wants to change, he will change. It is not compulsory that he will obviously change. He understand himself. How he understand himself, if you want to get an intuition, the intuition is to see the slope of this function at that point.
Okay. Yeah,
You got the point, right?
Yeah.
Anyone else? Nikhil, how to choose the accurate step size? Yeah, that that only I'm telling now, that I cannot tell now what is the accurate step size. So you just need to basically mention this callback, and TensorFlow will choose your step size automatically. And how it does mathematically, it takes the slope at that point of the function and then he chooses it. Lavisha, is it clear? Okay, yeah. Okay, Nikhil's doubt. Where are we inputting the learning rate? See, Nikhil, basically, when we mention this, LR. Okay, just let me show you here also. Actually, when we mention this optimizer Adam, so Adam has a default learning rate. Let me actually, the value, if I am right, is the value is 1e minus 5. But let us see Adam optimizer learning rate. It is a default learning rate. See. Yes, see, Adam learning rate is 0.01. Sorry, I was wrong. Its default learning rate is 0.01. Where it got? See, oh no, they have mentioned it. Maybe default. Actually, I don't remember. I think it is 1e minus 5 default learning rate of Adam. See, default parameter, default learning rate it is 0.001, 1e minus 3. So it takes a learning rate by default, the starting point, the starting step size, it takes on its own, and rest this callback takes care himself. It takes care himself, right? Now is it clear, Nikhil?
Yes, sir. Okay.
And also, I am focusing. This is very useful. Why I am telling this? Quite a time ago, I was participating in a contest, and I wrote the full code, and I forgot to use this thing, and I was getting a little low accuracy. And once I did this, I got a huge change in my basically accuracy. So it is a very important thing. So that's why early stopping is not that important. It's on your own convenience. Now there is one more important thing. These callbacks are just for your convenience, not compulsory, but yeah, good to use, because why should you, it is very simple to use, then why don't use it? So there is one thing known as callback, known as checkpoints. So see, let me explain. So I told you already that model run in epochs, in iterations. So how will you know, say it run in 10 epochs? So it can obviously happen that your results were quite good in 8th epoch, and in ninth epoch your result basically drastically decreased. Not drastically, they will not drastically, but decrease somehow. For example, in your say 8th epoch you are getting 90% accuracy, and in your ninth epoch you are getting 88% accuracy. So finally, obviously, you want to keep the 8th epoch, right? But as your model is trained for 9 epochs total, then it will show at the end point, it will show the weights of 9th epoch, right? You are getting this, right? So, but I want the weight of my 8th epoch because it was my best epoch. So there is a callback known as TF Keras callback checkpoints. What it does is, after each epoch, if the new score is better than my previous score, it saves the weight in a given path. I will tell you. You can mention any path wherever you want to store those weights. It will store the weights so that at the end of your model training, you can load the best weights. You don't have the ninth epoch weight, but you have the best weight. You can load the checkpoint, and it only saves the one file, the best file. Like initially, say in the first epoch, your score was say 50% accuracy, it will save a file because initially there are no checkpoints. In your second epoch, your accuracy increased to 60%. It will override that file, override the weights, override the parameters. Now in third epoch, your accuracy somehow decreased, maybe say 55%. Now it will not override it. It will continue. So that way, at the end, you can restore your best weights. There are two major advantages of this. First, I already told you that at the end, you can load your best weights. Second advantage is that say if you want to train model in parts, like for example, say you trained a model, you don't have much time now, you need to close your laptop, you can save the checkpoints in your drive or maybe download locally on your computer, and next day you come, you can start your model from those checkpoints also. You don't need to start from initial beginning, you can start from these checkpoint also. Here I am saving my checkpoints to my drive. See, I have mentioned the path of my drive. Let us see if it came to drive or not. See, it already came. I deleted it at the start of the session if you remember it. So it already, or you can see the time also if you want to check. See, time is 2:26. So right now 2:28. So 2 minutes ago it was updated. So now if I want to say download this, I can download it easily. If I want to tomorrow again run this code for, right now I run it for 2 epochs only because of less like, obviously right now why to like train it for, why to waste our time running it, because logic is pretty clear. But tomorrow if you want to again run it, you can just load your weights from these checkpoints and just run it instead of running your code from start point. Is it clear? If this is clear, I will move forward. Anyone? Nikhil?
Yes, sir.
Yeah.
Sir, I have a small doubt actually. When we were defining the layers of this model, are the built-in functions defining the weights themselves or?
No. Yeah. Nice. So most of the built-in functions have some default value of weights, maybe random weights.
Okay.
Yeah, but some have some good functions to like have the weights. Okay, now I have one question for you. Tell me, when I was adding the layer of a vision net, what would be my weights for that layer?
Can you repeat again?
When I was adding the layer of a vision net, a vision net layer.
Yeah.
The first layer, transfer learning layer. What weights was it taking? I showed you in the code also.
Okay.
Logically, what do you think? Should it take a random weights?
No, I think it should take Unity, I guess.
No, it will take the weights of a vision net, the already trained model. I mentioned here, na, weights is equal to image net. So Google already trained this model. This is the advantage of transfer learning, na, that I am using his weights.
Okay. Yeah. Predefined.
Cool. We got it right.
Okay, so they were already defined in the model.
Defined, but Google trained it and put it in the TensorFlow implementation. I also sorry. Oh my. Yeah, I also showed you here, na, that there was a link to download those weights. So yes, see, here it is saying downloading data from this link. It is, so these are the weights only. Cool.
Yeah.
So,
and in the last layer, there will be cross entropy to calculate the label.
There is binary cross entropy. This is just a loss function. Huh?
Yeah. Okay.
Okay. There is Rajat's doubt. What would be the last layer? Would it be random? You mean the weights of last layer? Like the dense layer, initially it would be randomly assigned, like however the implementation of TensorFlow is. But as you train, it will automatically change, obviously. Yes. Yeah. Cool. Cool. Okay. So now our model is trained. We need to make a plot. This is just a simple plot. If you want to make a plot of loss and accuracy, just a simple code. I don't think I need to explain this. You can just see yourself. This I have provided a code to load model from best weights. I already told you that I saved the checkpoints here. So what I'm doing here is I'm deleting my model using delete model, again building it and loading just the weights. So see. So this is how this thing works. So now once you have loaded the weight, maybe you can start your training from this point. Then obviously it will save you a lot of time. So this thing is clear. This I have provided a code. I will show you and then I will explain it to you. Okay. Oh, sorry, that was a function. Yeah. Okay, let it run. Now we came to the end point. Like we have got the data, we trained the model properly. Now let us come to the testing time. There is very क्या कहते हैं? Yeah, there is very important thing known as test time augmentation or basing ensembling. See, ensembling is very important thing. No, sorry, not very important, very cool thing. Actually, I also didn't know about this thing. I came to know this from one of my friends, and like it is like very nice thing to get. Like this is mostly used to get good score on leaderboards whenever you participate in machine learning contests. But here I have not tell you advanced ensembling thing because like it is out of scope for the beginner level. But the basic ensembling. Let me tell you the logic behind it. And there is one more thing known as test time augmentation. Don't focus on code, just listen to me. So see, now we have model. Forget about previous thing. Don't, if you have any doubts of previous thing, I will take it afterwards. But don't worry about them. Now we know how to take data and we know about augmentations. We have model. Now let us treat this model as a black box. To this model, if you input an image, it will give you a label as an output. Now I want to get the prediction on my test data set so that I can submit on Kaggle or AI Crowd to get a score or maybe to check my accuracy. So one option is to just use model.predict on that image and it will give you output. One case is this. That is also a good thing, you can do that. But one advancement to this is, see, what we will do, we will apply augmentation on test data set. See, I will basically apply random augmentation 5 times on my test dataset on say one image. So for example, I want to get the prediction of one image. Then initially it was giving me say cat. Now I will apply 5 augmentation on that image and one original, total 6, or say 4 augmentation on that image and total one original, say 5, and I will run prediction on those 5 images. Cool. And I will take the average of those predictions and then I will output my result. So this is known as kind of ensembling, not exact ensembling, kind of ensembling. So test time augmentation means applying augmentation at the test time. Like this TTA steps means test time augmentation step. I have applied 5 as I already explained you. What it will do is it will apply 5 random augmentation. Basically, it is just a for loop. See, I have applied a for loop on this TTA steps, and it will make the prediction on test dataset 5 times and average out the results. So can you understand, like basically logically, if by mistake my model made a mistake on one image, I applied some augmentation, it can happen that augmentation he can understand the better. For example, let us take an example. For example, a dog image was very dark as in there was no light in the room and you take the image. So model might not be able to understand the properly what is that image. But in your augmentation, you applied brightening. There is one brightening augmentation also. You applied brightening. Now your model can understand that lightened image properly. So he will give a good result on that image, right? So that is the use of applying augmentation at the test time, so that you can get better results. It is not a compulsory thing, just a cool technique to get good scores. So this is known as test time augmentation, and averaging out the results of different loops, different predictions is known as ensembling. Is this thing logically clear? Why we are doing this? Just tell me this. Anyone? I guess this was simple thing. Rajat, is it clear? Yes. I will ask some random guy now. Oh, Trinath, is it clear?
Yes, sir. It is clear.
Okay, Trinath. Okay. I already tell you what. Okay, I will ask afterwards. So see, for the implementation wise, you can just loop over these TTA steps with a for loop, predict, and prediction dot append, just appending in the list and taking the mean. Mean means the averaging out. This all is the implementation thing. You can obviously see it yourself only. I don't think I need to explain this. Now our last thing is our confusion matrix. I will tell this. Before that, I will ask one doubt. I will ask from Trinad only. Trinad, tell me, can I do this thing? Like I train 2 different models. One model is EfficientNet, as I do this time, and one model is Inception. Cool. like say you say Trinad trained efficient net model, and say Hardik trained inception model, right? Both of them are getting approximately 80 score in range 80. Trinad is getting 80% and Hardik is getting 82%. So, but they are a team, so they can combine their model. How they can combine their model? Trinad will give predictions made by his model, and Hardik will give prediction made by his model, and they both will average out the predictions and then give the results. This is also a kind of ensembling, that taking the predictions of 3 to 4 models and then averaging out that. Why is it useful? Let me tell you. So inception is a different kind of model. EfficientNet is a different kind of model. They have their own properties. Maybe it can happen that inception learns some things better than EfficientNet, and EfficientNet learns something better than InceptionNet. So EfficientNet will give good prediction on those set of outputs, and InceptionNet will give good prediction on those set of outputs. And if we basically average out their results, so we can accumulate the benefits, the qualities of both the models, right? Rinath,
Yes, sir.
you both are everyone is getting this point, right?
Sir, like accuracy of exception is hello.
Yes, yeah, I
Yeah,
can hear you.
accuracy of exception is lesser than efficient net.
Inception.
Yeah, the inception. Sorry.
Yeah.
So, is there any advantage of inception model over efficient net? Like,
actually, if you are asking in technical terms, then it depends upon problem to problem. But I just took an example.
yeah, okay.
Actually, there is one doubt none of you asked. Okay, Nikhil, I will ask it to you. Okay, but what if the wrong prediction on both models are not for same instant or inputs? Okay, actually, this question arises because of the question I am going to ask. Okay, Rajat, you tell me. Okay, see, one model gave me a zero prediction. Means one model identified one image as a cat, other model identified that image as a dog. Now, how can I average those both results? Like, what do you mean by averaging? Should I take 0 plus 1 by 2? Any guess, Rajat?
No.
So what should I do? Actually, you guys should ask that out. So the thing is, your model outputs 0, 1 label, but how it outputs actually is, it basically outputs a score between 0 to 1, maximum frequency. What do you mean by maximum frequency? There are only two models, and one is saying cat and one is saying dog. So what do you mean by maximum frequency here?
No, not in this case. If we have more than two models,
Good suggestion, but that is not a correct one. Let me tell you, then you will be more clearer. So you should ask this out, but right. So thing is, your model gave 0, 1 output, probability cat by model. Yeah, kind of, you're right, kind of, Varul. But yeah, let me explain. So basically, your model gives an probability output from 0 to 1. Actually, this is not an exact probability, but you can think it of as an probability. So see, as 0 was labeled for cat and 1 was labeled for dog. If I gave you score that my model said that my this image is 0.9, then it is more towards 1, right? So I will say that it is dog. So we take a threshold as a 0.5, that if my probability of prediction is less than 0.5, I will say it is a cat. And if it is more than 0.5, I will say it is a dog. So this way the model works. Cool. So everything means that if, for example, VisionNet is a very good model, and he says that this image is dog, I am 80% sure. So it will give output 0.8. But InceptionNet is not much sure. He is saying that it is cat, but he is not much sure about cat. So he is saying that I am 40% sure or very less sure that this is the cat. So when we average, it automatically moves towards the side of the dog, because EfficientNet was much powerfully saying that it is a dog. Are you getting the logic behind this?
yeah, so we are taking on averages of the both, average scores of the both.
Yeah, average score. We are not taking the average of 0 plus 1. We are taking the average of probability.
Okay.
Yeah.
Like from cross entropy function.
No. Sorry. Cross entropy. If you want, we have less time, so I'm not showing you. If you want, what you can do is do one thing. Print this predict once you run. You will obviously see that there are scores. You can experiment with this code because this is just a Python code, and then you will be much more clearer. I told you the logic, right? So, sir, we have to look how much confident both model are. Yeah, that prediction model gives na. See, what I was doing here was, see, uh, yeah, predicts is equal to model dot predict. It is giving me a list of probability values. Then I am appending to it my list and then taking mean of my probability values. Just experiment with this code. I already told you the logic. You will be much more clearer, I'm sure. What if the wrong prediction both model and I guess, yeah, Rajat, everyone is clear right now. Cool. So last thing is the confusion matrix. Already it is 2:43. I had one more notebook, but that I will explain quickly because it contains most of the tricks used in this notebook only. Sorry for being late, but yeah, it take time to take doubts and like explain from beginning. So there is a confusion matrix. This is just an cool additional technique. So what it does is, so see, you have what are the possible options? There is one image. It is a dog. Your model can predict it as a dog if your model is good, and he can predict it as a cat if he is not good. The other option is the images of a cat, and your model may predict it as a dog or may predict it as a cat. So there are total 4 cases that your image was model dog, your model predicted correctly as dog. Your image was dog, your model predicted incorrectly as cat. Then your image was cat, your model predicted correctly as cat, and then your image was cat, but model predicted wrongly as your dog. So there are 4 total cases. So this is where confusion matrix helps us. So this is a matrix of size 2 cross 2. If there are more than 2 labels, then obviously that cross that size. So this told you various important things like F1 score, precision, recall. Due to less of time, I'm not explaining this, but I'm sure you can like search from net and just understand the meaning properly. But the key point here is there are different type of things, so we can like plot that easily using sklearn's where this is see confusion matrix function. Confusion matrix I basically imported here. See here. Cool. So this is just a metric to check at the end if your score is good or not. And many machine learning contests, actually most of the machine learning contests take F1 score instead of accuracy. Actually, there is a good thing why F1 score is important than accuracy, but due to short of time, I am not explaining. Let me include the link in the slide why F1 score is. It is a very important thing. Just read this thing, then you will be like surprised. This should be a good blog. Yeah, I will include this link in the slide so that you can read it. But yeah, logic is clear. So okay, cool. Yeah, so this is how now we ended this computer vision model. We let me give a recap. We learned how to basically get the data, how to apply augmentation on data, about data frames, how to take transfer learning models, then various cool techniques. We now from one notebook I already showed you how many models, efficient net inception. So you know all the models. You just need to change one name and you are good to go. Then you know about confusion matrix. Ensembling is a very advanced and very good technique. It is not a beginner friendly technique, but it is an advanced technique. Very nice technique. Then yeah, this way I told you a lot of good techniques also. So this was the problem and this is the challenge. If you want, you can basically what do you say, make a submission by predicting on the test data set. Okay, so this was the computer vision part. The next part of the workshop was of explaining the NLP problem. But actually right now it is 2:46. But yeah, I am ready to take that too. It will take at max half an hour because most of the things are clear with this dogs and cat, and that will not take much time. So if you guys want, I can extend the session for 30 minutes. I don't have any issue. Maybe 5 to 10, like maybe put up in the chat if you are interested. Then I will continue. I will give you a break, maybe of 5 minutes if you want. If you don't want to attend, then also you can comment. I will not mind. So yeah.
So what will be discussed? And
okay, so the way in this notebook I told you the dogs versus cat problem na, in the basically NLP problem I will explain you a little bit only code of fake news versus real news challenge. So, but I would encourage you to attend that, because that is not a tough thing, because most of the things you learned here only, and the price which I have put for the workshop today is also related to that code. So that's why. Okay, I am fine with extension. So okay, cool. Okay, I will. Okay, let me give you 5 minutes break, cool, or more. We can start at say 52 or maybe 52, 53. Or do you want more break? Anyone? If you are fine with 5 also, then also please comment in the chat box. 5 minutes will be okay. Okay, cool. Then okay, just maybe go through this code or maybe do anything, and then we will. I will just take half an hour at max more, and then we will explain this NLP thing. Till now, till then. Yeah. So let's start, right? Cool. So yeah. Okay, let me give you an intuition, like the way I give you the dogs versus cat intuition. Let me give you an intuition for NLP task also. So there are two major fields. There are very many other fields also. Two major fields in machine learning. One is computer vision. Computer vision means like uh, understanding the images. Like dogs versus cat task, you obviously know that it understands the image. Okay, my voice is audible and like screen is also visible, right?
Yes, sir.
Anyone? Cool, cool, cool. Yeah. So
Yes, sir.
yeah. Thanks. Yeah. Cool. So computer vision task means, as the name only suggests, computer vision of computer. That computer should understand the images. So now, what do you mean by NLP? NLP means natural language processing. So it means that now, as human, you are human. You can see the images. As I gave an example, newborn baby can understand dog if you show them. Newborn baby, after some years, obviously, can read also text and can understand the meaning of text also. Na? You humans can also understand the meaning of text. For example, let's take a problem and see, like listen this problem carefully. It will be the like this is the problem for which I have kept the price. So yeah, the problem is I gave you the text of like some text. Okay, some text are written. Like one may be a comedy text, one may be a news text. News text as in like some person is speaking news, maybe on some channel, and I wrote its subtitles on a text, right? And I gave you those texts. One is of comedy field, one is of news field, one is on programming field, and one is of my only this ML session. So after reading those, you can obviously tell na that this is comedy surely, this is news surely, right? You can tell this. So obviously if you can tell, then obviously machine should also tell. So this is the problem. Now this is the NLP problem: understanding the text, understanding the language, and the basically transcripts and all that stuff. This problem obviously I will explain you at the end. This is the problem which is present for your today's workshop's prize. The person with the highest score on this problem will be given the prize, who is participant of this workshop. But I will explain this problem later. Actually, this was the contest set up by us only as a part of Felicity. We are the authors of this contest. You can check here. So yeah, but let's forget about this for right now, and I will explain you this afterwards. So, but right now, obviously I will not show you the. Oh, 1 second. Sorry. Where it come? Yeah. I'm just keeping it. Yeah, just so that I don't need to update it. Cool. Yeah. So this was our problem, but obviously I will not give you the code for this problem. This is a running contest. It started yesterday and is up till 7th March. So the problem which I'm going to do right now is this fake news challenge. This is also one of the AI crowd's problem. The problem says that you are given a news field, a text of the news, and it has two different labels: a fake news and a real news. Fake news, as you already know, various news are like forwarded on WhatsApp, like which are fake news, like that way. And real news, obviously, no. Like previously we have two labels, dogs and cats. Now we have two labels, fake or real. And the field, the data set given is the like basically the news, the text of that news, right? You need to understand from that. Obviously you can understand, like there are pretty like some common words in real news and there are some common words in fake news. So if you see a lot of those news, maybe 20 or 30 of those, both type of those images, sorry, text na, then you can pretty easily understand what is the fake news. So this is our task. So for this we will use a model named as BERT. Basically we will use distill BERT, but there is a model known as BERT. Now here also we will use transfer learning concept as we did previously. And here there is one more good news, that the news that we don't need to put more layers here. Like I am going to use one new library known as K-Train. K-Train is basically say a higher framework of Keras library, TensorFlow Keras library. It is very useful library, literally. Why useful? Because the code is very small and you don't need to put any layer on your own, and it will do everything on its own. So you only need to understand the logic, what is happening. Okay, there is one reason behind like why I am teaching you this, why I am doing the code walkthrough of this challenge, this fake news, and how it is related to this thing. So obviously I will not tell that. So you need to figure that out, and maybe this code would help you. I have provided the dataset here. They have provided here the AI crowd people provided train and validation files differently. So I will not need. I don't need to create their split from like on my own. Cool. So I already told you I am using Ktrain library. Let me show you that also. Ktrain. It is a very nice library, literally. I will show you one thing at the last, and you will be amazed to see that. So this is the library. This is the repo, and you can see that. Yeah. So let me move forward. Firstly, let us install Ktrain because it is not pre-installed on Google Colab. So this is just a terminal command. If some of you use, like most of you might be using terminal. So firstly, we installed this Ktrain. Then we have just imported Ktrain, Pandas, Seaborn, I already told you. And this is a Python library to make plots. Just a simple thing, so no need to worry about that. Cool. So it installed. Now let us run import. Again, I am mounting the drive as I already told you. See, now I already mounted the drive. So in my drive, there are these zip files. I am unzipping them now. Okay, it is taking time for. Okay, it has unzipped file. Let us see what are the files present. See, there are two CSV files present, train.csv, val.csv. There are two files present. Here I mentioned the train path, train.csv and val path. Maximum length, batch size, you already know. I will tell you what is the maximum text length afterwards. Batch size, you know, learning rate. Here I need to mention learning rate on my own. Like there was an Adam thing, na? Adam has a default learning rate. Here I need to mention it on my own. Epoch I have just taken one because we have lack of time and we don't need to. Basically, we don't need to run full code. We don't have much time. So let's define the constants here by running this cell. Now, as I already told you, the first step of any machine learning problem is exploring the data. What is the data? So the data frame are the best option for any problem, and you will most probably use it in all of your problems. So let me load my CSV file in my data frame. How I load? pd.read CSV. Just simple command pd.read CSV. Okay, let me. Okay, this you already know, na, length of train.df. It should be okay. Let me don't confuse you and let me use train.df.shape as I used earlier, right? So it is saying my total is 2,32,000 text are given. I printed the train df, so it is a table with two labels, text comma label. Label are real or fake, and this is the news. See, count granted by a 5-4 vote, a request made, and this kind of, this is the news text and this is the label. Let me plot this distribution, that how many labels are for real and how many for fake. See, now I show there is a lot of difference. In previous it was not a difference, but here there is a difference. So there are a lot of data points for real news, but less data points for fake news. But our aim, what is our aim? Our aim is that the distribution between train and val should be same. I don't worry that it is less or it is small. So let me load val data frame also, and let me show this. So as you can see, the distribution of both is same. So it is very simple. I've just loaded the data frame. CSV files, my data is ready. Is this till this? I think it should be clear because it is same thing, right? Just please reply quickly so that we can end in half an hour. Anyone? Okay, cool. Yeah. If it is not clear, I don't think it should not. Yeah, cool. Cool, guys. Yeah, so this is obviously clear. This label is just I'm preparing for my use. Yeah, just like don't like unique labels. Now comes my main task: pre-process data and create transformer. So what is a transformer? So see, now this is only logical part which you need to understand in this full notebook. Rest all the part is very like similar to previous notebook, right? Okay, cool. This is only for main logical thing here. So what are transformers? When you have a sentence, say, my name is Kanish Anand, comma, I am a student of Triple IT Hyderabad. There are two this sentence, comma or says full stop. So you need to feed this sentence to your basically model. So there may be various punctuation. Maybe I have used I am Kanish Anand, I am from Triple IT Hyderabad, exclamation mark, just randomly. So this exclamation mark is of no use to my model. Na? My model just concerns with the what you say text. So I will remove this. Basically, transformer does various tasks. It basically pre-process the text into numbers. Basically, it assigns numbers to each of my word. Basically, in the libraries which we are using, they have a dictionary stored in themselves. What that dictionary does is it maps all the words to some number. Why to some number? Because we will be training the model on that number. You don't need to understand properly in proper detail because this is just an abstract concept. But the logic behind this is that transformer will do this type of stuff, converting text to some known thing, maybe one-out encoding or some labels or some numbers, and also removing stop words and punctuation marks because that are of no use for us. That all things transformer will do. So what I am doing here is, oh, I forgot to tell you one thing in the dogs versus cat notebook, but I will tell you here. Yeah, correct, Rajat, exactly. It is a bag of word kind of thing. Okay, I did one thing in the previous notebook. I did here also, and in previous notebook I forgot to mention. Here I have now just took 10% of the full data set. The reason being just because in the workshop I cannot run full on model on full node full data, so because it will take a lot of time. So I just basically take 10% of the data. So you can just comment this out. Don't worry about this. Just comment this out. The same cell is present in the previous notebook also. Just comment it out. So don't need to worry about this. That's why I've put comment also here. So according to the reason only being that in this lecture I cannot like devote time on running the model. Now this K-trains transformer accepts the labels and the text in the form of list. So I'm just converting it into the list. Train text, train labels, to list function is just converting to list. It is just simple. If you want, let me print out. Let us see val underscore text. See, it is just a list of text. Cool. Val underscore label. See, it is just a list of it is just a list, right? Don't need to worry about that. So this is our main thing. So the previously we were using a Vision net model by specifying tf.keras.efficientnet. Here we need to specify model name here, and you are good to go. Here I have used distill but uncaged. I will tell you about just a little about these models, but let's see after that. Here I have done text transformer model name. Okay, sorry. Max text length I took earlier. I will tell you what this is. Class is equal to label list. Here we need to pass what are my distinct classes. I prepared it here. Unique labels. This will prepare my transformer. Then transformer dot pre-process. I am pre-processing my training text and training labels as Rajat said. This is like bag of words thing. Then I'm pre-processing my validation text and validation label, and then just this is just an basically declaration of model transfer dot get classifier, and this is just a learner to get model, like basically the last step where we were giving model dot basically assigning the training data and val data to that and batch size, kind of say generator thing. So these are just a simple steps. Don't need to worry about that. Now let us come. What is the max text length? Max text length means what are the maximum number of words in your text. Why it is needed? Because when we are doing this pre-processing, we are basically converting our text to say a one-out encoding or something. So we need to resize the vectors initially. So that's why we need to specify a max length. Say if your words are like, if your sentence is less than this maximum number of words, then there is no issue. It will fill 0 at those places. And if it is more than that maximum length number of words, okay, take care that these are number of words. Like in the beginning I confused with this. So these are the number of words and not the number of characters. Like your sentence is I am Ganesh, so there are 3. And if there are more number of words, it will automatically take first those words, right? So why we need to mention, because obviously computational power also has some capacity, so it cannot train for large number of that, right? So this is much about this. Okay, and okay, once I run this, it will do pre-processing. Pre-processing means converting text to a simpler method, which model can easily train. You don't need to worry about what it is converting. Just copy paste this code and you are good to go. But the logic is converting text to a simpler method which model can understand easily. Like previously we were converting images to our arrays, right? So that here also actually it is converting to arrays only. Okay, so yeah, see, this is our everything is prepared. This is our thing to fit the model. Learner.autofit. LR means learning rate, which I defined earlier. And epochs. Let me run this out. Actually, this is taking a lot of time because DistilBut is a kind of heavy model. So I need to stop that in between. But yeah, till then I will explain you a little bit about this model. Is everything clear till this point? Anyone? Mukund, is it clear?
Yes, sir.
Any doubt?
No, sir.
Cool. Okay. So here we use distill but uncaged. Uncaged means caged, uncaged, you obviously know, capital letter, small letter. So there are different type of models. BERT is a very famous model. Like BERT is the most, like till the time, not most, I would like, not the best. There are maybe some more models better than that. But yeah, very nice model for these NLP problems. Most of the people use these only, BERT, distill BERT. Now there is one difference between BERT and distill BERT. BERT is bigger than distill BERT. Distill BERT is little smaller, but accuracy difference is not much. But time DistilBut takes to train is quite less than the BERT. So only that is the difference. They might have reduced the number of layers and number of parameters, due to which it is taking less time. And obviously there would be some decrease in the what you say accuracy. So this K-train by default use Hugging Face models. Like initially, Hugging Face is basically say an organization who have implemented these models. Like TensorFlow implemented those EfficientNet वगैरह ना. The same way this Hugging Face library has implemented these models, BERT, DistilBut, and this is the most famous. There are various type of models. Based on your use case, you can choose one, and you just need to change name here, nothing else. Just change name here and you are good to go. Okay. You see, here you can see a lot of models. Actually, there is a page where, okay, just give me 1 minute. I guess this should be that. Yeah. Perfect. Yeah, this is the link. Here they have mentioned BERT based, uncaged, different type. You just need to copy paste this name, copy this name, paste this here, and that model will be running. So see, there are various models prepared by this Hugging Face for you. This GPT-2 is very nice. Now there is GPT-3 also, which is again very nice, but that is not free, I guess. It's still BERT. You can understand, like read the specification and maybe use, but mostly DistilBut and BERT are the most useful. Let me include this. Okay, cool. Yeah, so this was the thing, and now my model is running. Okay, let us wait for full epoch so that I don't need to stop in between. Till then, if you have any doubts, you can ask. See, it is running epoch by epoch. Total epoch number are 182. Right now 141 are done. And it is saying loss is 0.449, accuracy is this. And it is also saying begin training using triangular learning rate policy with maximum learning rate 5e minus 5. Triangular learning rate policy, you can search from net what it is, exact meaning of that. If you have any doubts, you may ask till this model is running. Okay, let's point. Okay, I cannot pronounce your name. Rishabh, is it clear? Rishabh Singh. Okay, yeah. See, yeah, it is almost done. And for transformer also, I mentioned one link here. This one. You can understand transformer in great detail from this link if you want to. Otherwise, you can just treat it. Yeah. So model is run. Now history is there. So now we want to save our model. Like the previously we saved the checkpoints. Now here also we can apply checkpoints, but maybe I forgot to apply that. So you can directly save the model also this way. Predict this way. According to K-Trend, predictor.save model, and it will be saved here. See model. What files it contains this config.js, tf model.h5, tf model underscore preprog ASO. It will contain the architecture as well as the basically your weights of the model. Now I have mentioned the code of plot, but it will not make plot because this is loss versus epoch. But we ran only for one epoch, so there is no plot. But yeah, only for your reference, I have added this code here. As confusion matrix, it is very easy to draw confusion matrix in this K-train. Just 2 line of code. Class is equal to transfer.get classes and validate class in this way. See, it's very simple, and here we are plotting it. So previously it was like the images of dog and model correctly identifies as a dog or wrongly identifies as a cat. Here text can be a real news, model can correctly identify as a real news or maybe incorrectly identify as a fake news. Cool. So this is the confusion matrix. So now comes the best thing of K-Train, like literally best thing. Now, okay. Kunal, ask your doubt. Shubhang.
So I want to know what is hugging based birth model.
Yeah, Hugging Face is basically an organization who has implemented various models for you guys, so that we can use them abstractly. Just
So which kind of models?
NLP models. NLP models.
Okay. Okay, sir.
Cool. Okay. Okay, cool. So now comes the best thing of our this K-Train library. So K-Train has a feature. Now see, for example, let me take an example. Yeah. Okay. Which example should I take? Maybe there is a comedy sentence. Maybe if you want to recommend any, you can put in the chat. There is a comedy sentence. So there may be some useless words also. Like this is something like just a simple sentence. So some words would be there who are who would basically tell model that hey model, these words, these particular words tell you, like for example, for a news text, there may be occurrence of breaking news in the text or in the audio clip. They have multiple times they have said breaking news. So just by listening to that breaking news word, your mind can say that this is a news thing. So some words will contribute more to your prediction results, some words will contribute less, and some words will contribute to the reverse side that way. So this way there is different contribution of different words of a given text for a given prediction. Can you like understand this? Like for example, if you are what is the okay, cool. Yeah, for example, if you are listening to a news channel and you don't know that it is a news channel, you are just listening an audio, and if they are saying breaking news, this happened, that happened, so you can understand. If you listen the word breaking news, you can categorize that audio as in the news category. So is this point clear, that some word will give more contribution and some word will give less contribution? Okay, Hardik, is it clear? Or Devanshi, is it clear?
Yes, it's clear.
Cool. So some words will contribute more and some words will contribute less. So K-Train offers us a feature to see which words are contributing how much, like probability value. So first, and one more thing K-Train shows us is it also shows us automatically that in the validation data set at what are the main points at which our model is failing. And you can simply do learner.view top losses. N is equal to 10 means you want to see top 10 wrong prediction made by my model. You can do that in TensorFlow also, but it has not provided any inbuilt function. You can use a for loop. Maybe what you can do is for loop over full validation dataset and display the ones having highest loss, maximum 10 losses. Cool. So see, it is running top 10. It will give top 10 wrong predictions in my validation dataset. Yeah, see, it gave the ID, then it gives the loss. It says true label was fake, but predicted label was real. Let us see this ID. This ID is 2361, right? Let us copy this ID and paste it. Oh, I already okay. Both the times it gives a number, very nice. Okay, before this, just one more thing. If you want to predict on a random text, like say Harry Potter, though it is not a cool thing, maybe say breaking news. Uh, uh, there is a bomb blast. Okay, so it predicted it is a real news. It's his own wish, like how it learned. So you can just load this predictor and just do predictor.predict and put your text here this way. Like if I put, let us try if I put India won. Yeah, it is on also it is giving real, but yeah, cool. So now as it was giving highest loss on this ID, let us see what this element was. From data frame, you can index the element by using this ilog thing. So it has given the text. Text is this. Okay, we can see here, a panel of European medicine, this, and all. And its true label was fake, but our model predicted it as a real news. So that is an issue. Now we will see what words contributed to like for this model, what words contributed for its true prediction and for wrong prediction. Firstly, you need to install this package. Basically, this is done using ELF5. This ELF5 thing. You can do this on images also. So yeah, but Ktrain has provided an easier way. You can just write predictor.explain check text. See, I am running this thing. And this thing is known as explainable AI, that you can your model will explain you that hey, this word was more good to me and this word was less good to me. I will show you one more example on the images also. See, the words which are green are contributing towards my correct prediction, the prediction my model made, and red, for example, my model predicted this news as real. Then the green words are saying that hey model, yeah, these words contributed to the real and this is the score, 0.231. The more darker green it is, the more it has contributed towards it. And red words are contributing backwards to the opposite label, that hey, you are doing wrong, go back, this way. Cool. So this is the thing. And here I have provided a code to load model from this file. So just for your reference, your wish you want to, yeah, for your reference. So this is the explainable AI thing. Let me, what is bias? What is bias? Where have I used bias?
Sir, in the explainable AI, can you go to the tab? There is something which is not highlighted, minus 0.091 bias.
Where it is? Sorry, I cannot.
Sir, the red and green ones. Can you go there?
Oh, this one.
Yes, sir.
Okay, this is actually, I guess this is saying that this is contribution plus 8.805 minus. Actually, I am not. To be honest, I am not also sure. I guess it is giving some metric of this probability value, that how much it is like saying that this is contributing. This word is contributing to a prediction. Cool.
Okay, or is it not? I didn't understand, sir.
Actually, I am saying that the bias is a metric. See, when I'm going to any word, it is giving a number, na? Okay, why it is not giving now? Yeah, minus 0.257, then plus 0.194. So this bias is some metric according to which it has decided these values. Maybe it can be probability also. I'm not sure what is this metric exactly. Just a metric. Cool.
Yes.
Okay, one more doubt. Sentence we are inputting containing keywords should be in vocabulary bag of words. Is that right? Yeah, it is right. It is right. And like that contains most of the words. But yeah, obviously if it doesn't contain some word, then obviously it will create some issues. But you can see in the real life scenarios, you won't have like the words which are not in those bag of words. They also have trained a full-fledged model and then published. So they have tried to accumulate as much words as possible. So let me show you one cool example, not code. use ELI 5 with images. Okay. So in the dog versus cat, as one person asked earlier, that will it focus on the background or will it focus on the dog? See, it was the image of the dog and cat. Now we applied ELI 5. See, ELI 5 give colored this region. That this region is contributing more to my prediction. This face of the dog. This is not contributing much. This is contributing more. This is contributing towards cat. This is a multi-level problem, so that's why it is giving both the ones. But it is not putting this color on this background, right? Because we learned from a lot of images that see how good it is. Cool. Let me include this also. Yeah. So yeah, this is the use of ELI 5 library. This is known as ELI 5. So that was use of this library. Any doubt in NLP problem? Yeah. This was much about the code and problem link is here already. Any doubt in this? As we are at the end, I will explain the challenges, the prizes, and yeah, I will explain the prizes and little about this contest. I will not take more than 5 minutes now. Any doubts if you have asked now? Else we will move on to the last prizes part. Okay, cool. No doubts, I guess. So basically, we have put a price of 0.5k for the guys who are attending this workshop. Like they need to submit. Okay, let me introduce about this contest. This is an ML Battleground contest hosted yesterday only, 25th Feb, by our college team only. These are like the problem setters and all by our Felicity Threads team. The prizes, global prizes are this: first, second, third, and for triple ITH students, these are the exclusive prizes for triple ITH students. This I'm telling just about the contest. I have mentioned the link of contest here also for your easier reference. Let me put it in the chat too. Yeah. So this is the contest. It contains 3 problems. The first problem is tiring text. I will not. I've already explained this problem. It is related to NLP. Hay barrels is a problem related to computer vision, and tile slider is an great imaging problem related to say a gaming problem. Like you need to create a bot kind of to play the game. Not the bottomania kind of thing. You learn that like machine learning is needed, but we have also provided a simulator for that. When you open this problem, we have also provided a simulator. It is a game basically in Pygame. So here is the referral link. Here you can play this game also. Like you need to specify the input grid and you can play this game also. So you can try out this problem. And this is a beginner friendly problem and prices are also a lot. So I would recommend you to try it. Especially but we have kept the prices for this first problem only. The people like make submission till today night till 11:59 tonight. Right now also we have a lot of time, I guess. Or okay, suggest me the time if you want to change. I am ready to change maybe a little bit. So only for this problem I am considering. For this problem, the guy who is attending the workshop and secure the highest score in this problem on the leaderboard. Maybe you can make the teams also. This is a team contest of 2. It's your wish. We will give them a cash prize of 0.5k. Cool. So this is a thing. And yeah, and one thing is that this notebook, this fake news challenge notebook, is pretty useful for this. Now it's your wish how to apply that and how to not. Basically because this is an NLP problem, so obviously you can try out some NLP tricks we told you today in today's lecture. And this notebook is already with you. It's present in slide also, and I sent out this link, I guess, maybe or maybe not. I am not sure. I can't hear you. Can others hear me?
Yes, sir.
Yes, you're audible.
Cool. So this is oh my god. Hello. Yeah. So this is the challenge, and yeah. So right now I've kept the time till 11:59 p.m. tonight. Should I make it 23? 23, yeah. 11:59 p.m. tonight. So if you want some little time, tell me, or otherwise it is final right now. Like I would advise you to participate. Like if you have attended full lecture, like many of you, I can just name that who have attended lecture and asked out also. So if you have attended lecture, you should practice also. And this is a 10-day contest. Like this prize obviously is of 1 day, because like we cannot keep this open for 10 days, because for 10 days we have already provided a lot of prizes. So if you don't get the prize also, then also if you don't, maybe you don't have time today, you can practice it. Like till now also you have time till 7th March. You can maybe practice it at any time you have. But I would like highly encourage you to practice it. So I guess, yeah. Anything you want to ask from your doubts, any doubts? I have added the resources also. I will send this. I will basically add this slide in this doc in this drive folder only here, because I have already shared you this drive, and I have already shared you the notebooks also. But I have kept this links here also. So cool, I guess. We can do the same thing in C. Python, array, you can do the same thing in C, but it is very tough to do in C because you don't have any K-train, any TensorFlow in C. So you cannot do that in C in less time. Array, you need to just use this code, na? See, just try to, I can guarantee that just try to read this code carefully. Just try to understand the meaning, and I'm pretty sure you will be able to understand. See, what is this? pd.read CSV. What is meaning of read CSV? Read the CSV file. Simple. Python is Python is more simple than C. You cannot do machine learning in C easily because like there are a lot of libraries in Python only. So yeah, if you have any doubts, you can obviously ask me also. So that's not an issue. Or you can take some baseline codes from net. Also, such for all of these three problems, we have provided a baseline code also to take input and output. If you like, so that you're not stuck in this kind of task like how to take input. There is a getting starter code. You can check that. You can open that in Collab directly from here. Download that also. So yeah, cool. I guess everything is done from my side. Yeah, if you want to ask any doubts or any suggestion or anything, you can ask. Otherwise, we can close this session. Can you share anything? Yeah, okay. I will share. Also, I have mentioned in the slide too. So maybe if you don't have any doubts, you can leave, I guess. Or if you want to ask your wish. Can you also share the slides? Yeah, I will upload slides in this drive folder just after this meet. And drive folder is already with you, so no issues.
Sir,
Mm-hmm.
If no one has any questions, like I in the Felicity website, I saw the time to be 1 p.m. and I joined at 1. So.
Oh, you didn't receive the email?
Yes, sir, but I was in the class at the time. So.
Actually, there was a confusion from our side. Actually, maybe for the competitive programming workshop, the time was 1, and for this time was 12 only. So maybe there was some confusion with the website workers. So that's why.
Can I like access the recording or something?
Actually, I am not sure about that right now. I need to ask others also. So maybe you can ping me. So like I will tell you after confirming with other guys. Okay, let me.
Okay, sir. Thank you, sir.
Sir, what is your number?